Hello? Hello, hello? Is this working? Are we live? Does this link work? Is it going to blast me with audio if I click it? Wow, there's a big delay there. Okay, well. Yeah, okay, cool. So here we go. Live stream at like time that it is for everybody. Hello. It has been such a time. Yeah, today we are going to learn Plugdata together. I have been meaning to learn Plugdata for months, maybe 2 years, because I was actually going to learn Max MSP. Got a course on Max MSP. I was like ready to dive in, do stuff. This was still when I was like using Ableton as one of my main DAWs. I don't anymore. I use Reaper now, and Bitwig, and it's super cool. Some people have been doing really amazing stuff with Plugdata, and I am super excited to also dive in and make some really cool stuff. I feel like I have some ideas that might be worthwhile for people to have, if I can pull off learning all of the background computer math stuff to make it all happen. I have a pretty good grasp of what DSP is doing in the back end, like what the DSP is doing. But I have pretty not so much experience like doing very good programming. So this is going to be very interesting. I have some programming knowledge. I have made like small little scripts and stuff, but I have not dove into doing this kind of like intense. Like I feel like this is more intense than just, making a little script, because you're working with like block data of information. So yeah, it's going to be awesome. I'm so excited. It's going to be so cool. So yeah, you'll see my tab stuff come up every now and then. I am using this as my main display, just so you can see things pop up and out as we go. If the audio is good, please let me know. I'm so down to just, hang out. We're just gonna chat. If you have any questions, let me know. I'm gonna have many questions. We're gonna figure it out together. It's gonna be great. Yeah. It is gonna be a time, people. I just want to do stuff on Twitter real quick. Let people know. Put the little red beach ball on the icon, like you do when you are live. Do I do it as the first thing or as the last thing type of thing? Oh, and I messed things up. I'll undo that. Discard. It's fine. Hello? Anybody? Nobody yet. Okay, good. That means I can chat to myself all I want, and nobody can look at me. Don't look at me. Okay, there we go. Red beach ball. It means live, right? I'll just put the red beach ball as the first thing in my name every time I'm live. That should work, right? People know it's red for recording. Yeah, red for live streaming. We're streaming. We're here. We're together. We're together learning of Plugdata. It's gonna be a time. It's gonna be a great time. I think it's gonna be a great time. What's that? What was that thing? You can have stream markers? Oh, that's cool. Oh, and then you just like get like limited by the amount of time that you can do that. Ah, yeah, cool. That's very sick. Very cool, YouTube. Thank you. Man, I had like the most insane time earlier. Uh, LAN cable stuff did not work. I had to like dig through accounts to get this set up to kind of work. It was something. To get to this point. Hey, Soundkiller, what's up, dude? Ah, heck yeah. I'm so excited. Yeah, like so as I was saying, like I was like setting stuff up, scrambling, being like, oh gosh, I gotta set things up. Oh gosh, the internet's not working. Why? LAN cable now. Like freaking diving over machines and things to get to this point. Oh heck yeah. Yeah, thanks, man. Yeah, we're gonna have a great time. I think it's gonna be fun. We're just gonna chit chat, have some Plugdata, like working things. Gonna be learning. I have like a little basic thing that I want to build. Um, Something that I've made in like every DAW, and it's kind of my test to like see, oh, how does the DSP kind of work in this DAW? Like, is it the same? Does it use Butterworth filters? Are we chilling? How's the automation? Is it fast? Is it slow? So okay, so the first tool that I would like to build for Plugdata number 1. Please do excuse my handwriting, but I am going to be doing this more often so I can get better at using this tablet. Oh, heck yeah. Yeah, same. Yeah, it's just like there's so much to dive into, you know? And things aren't like generally just called like normal things. Like uh like if you're like building a crossover system, then you have like the Linkwitz-Riley like filter design that you can like go down for like Butterworth filter designs. You can use other filter designs, but Butterworth is pretty good because then you like two Butterworth filters in line of each other make a -6 crossover with the same phase, and then you get Linkwitz-Riley filter, which is really cool. We've talked about that in the last live stream, I think. I might touch on it again if we do end up like going down that route today. Maybe we do, maybe we don't. But for Plugdata 1, I would really like to build like this really super simple thing. We're gonna get into like automation a little bit, which I think will be nice. Yeah. What is it saying over here? Oh, no, that's fine. Yeah. Okay. Thank you, YouTube. It was like, oh, we recommend streaming at a bitrate of 20,000 kilobits per second, which is funnily enough what I did set to OBS to. But it's like, oh, you're streaming at 6,800. Why? And my answer is, I don't know. I did not set it that way. Anyway, yeah. So first thing we build. So we will be building the LS. What do we call it? I don't want to steal my friend's name for this, so I'm not going to. Radio. I don't know. It's not the most important. Let's just do, yeah, we'll just steal my friend's name. It's great. Like the HLP. We're building a very simple tool. My friend Saber, my good friend Saber helped me build this very cool tool. We've been using it since we collaborated in Ableton Live for like a long time. It is very cool. Very simple tool, very basic, very good start to learning Plugdata, I think. So what this tool is that you have a high pass. And what high pass is that it just removes frequencies that are below a certain cutoff point, and it is called that. You will usually see it called cut or cutoff, whatever the normal usage of that is for most people. But you have your passband, which is this side over there, and then you have your stop band, which is over here. We'll need to move a little to the left. Stop band. Yeah, very cool. So this is our first puzzle, is just getting the H in the HLP, which stands for high-low pass. Very, very intuitive, I know. It's very great. Yeah, very complex. I'm saying very, very much. Yeah. So first, we built our stop band and pass band system for our cutoff. I'm probably just going to use some like Butterworth filter because I really do like Butterworth filters. They're so just everywhere. If you open a DAW, it probably has a Butterworth filter in there as the default, just on like your EQ, default filter that is not analog designed. You'll generally see your Butterworth filter there. So cool thing about this is if we can get a one pole Butterworth filter, which literally just means a -6 dB filter. And I'll explain what that is in a second. We'll get into a little bit of filter design stuff, and then we'll like jump into building everything. So one pole literally just means 6 dB at the crossover, like -6 dB for every octave. Sorry, so it's -6 dB per octave is the actual expression. The reason that this happens is that if we draw our diagram again over here, then where our cutoff is generally going to be where you either have like -3 in decibels, or you have -6, depending on the filter design. So yeah, generally one or the other. And as we have said, we have our stop band and our stop band and our pass band. And between the two, we will need to look at if our stop band for every octave, so if we set this at 100 hertz, then half of this amount will be 50 hertz, right? So if we draw this as a grid, then at if this is 100 hertz here with this dotted line, then over here is our 50 hertz. And this change, this like angle bracket, or like this change that we see here, will be a net change of either -3 or -6, depending on, well, not -3. -3 doesn't really happen in this section. This -3 or -6 is just immediately at where the phase change happens for the filter. We'll get into how those diagrams look as well. They kind of look like this kind of shape. Maybe it's flipped upside down. It's been a little while since I've looked at this type of diagram. But yeah, it's going to be something like this, where you have 180 degrees positive over here. You have 0 degrees, and then you have -180 degrees for this section. So yeah, we have this nice little diagram system we use to identify if we have Butterworth filters or not. It's either going to be a one pole, which is -6. It's going to be a two pole, which just means ×2 for whatever this value is. So if we have two pole, we have -12. If we have three pole, we have 18. If we have four pole, we have 24, etc., etc. It just keeps like adding on top. So this is just a multiplier. You can think of it as of the pole number as just being a multiplication number for 6. You don't really get a half pole, as far as I know. Maybe with shelf design, maybe that works for that. But generally, this is kind of like the way that this works. I do want to see what is my shortcut for this. I don't know. Is it insert? No. Control T. Oh, it is Control T. Okay, we did change that. Cool. Or it just is that by default and mimics what live and all the other DAWs do. Cool. Weird for a drawing program, but nice. Does work. So yeah, this is going to be our first goal. Just get a Butterworth filter. So you can write it up over here. Let's do it in a different color because I like colors for this. So step 1 is going to be get a Butterworth. Step 2 is going to be actually controlling the crossover. Or cutoff. Control. Yeah, step 1, step 2, and then we will need to also figure out the automation for this first build. So step 3 is going to be automation. Now, automation is funny. I did actually dive into this a little bit to figure out how automation works, and it's quite cool. You have essentially like a feedback loop that you create. So if your chain is over here and you have your first block, then you essentially like feed this into another node over here, and then you feed that node back into the input of that. So this output goes out into a node, and then this node goes out back into this node, and then control. They just kind of like feedback loop into each other. So if this one changes, then this one changes. If this one changes, then this one changes. That's just kind of how that works for automation from the DAW. Yeah, that should be it. So let's get started on just doing Butterworth. So that's going to be here. I'm gonna actually start in the DAW. I generally don't like using Plugdata just straight up in a DAW. Sometimes it can crash quite easily. I found it can just be a little bit slow and finicky to type into, even if you enable the send all keyboard inputs the plugin. So yeah, let's start. How do we start here? New patch. We will call our patch something. Probably need to save it to do that. You can see I did try to do something before. I do want to separate this into its own folder. ls HLP, just for starters, so we can get our feet wet. HLP. Yep. Save. Yeah, cool. What was the shortcut again? Control E. Yeah, and then Control to just immediately toggle between the two. Very cool. Okay. Let's make you big. Very big. Why are you not render? Why are you not render? Render for me. Thank you. Okay, I think Shift was the shortcut for this. You just double click? Yeah, okay. Let's get a Butterworth filter, which conveniently both of these are. Butterworth low pass. We're going to start with low pass so it doesn't get harsh at all. We will need to get audio from the DAW. So to do that, we use either the ADC, which is the audio input from the sound card, but that's not really what we need. Let's go and check out. Just gonna switch the camera for a second. You're gonna see my face. Okay, here we go. So first thing that we need to figure out is inside of Plugdata. How do we get the audio in? And we can actually check over here. Do you think there is a help about no? No. Yeah. Okay, let's just go to the Plugdata help support or documentation actually. Because all I want to know is how to get the audio into an effect and then out again. There's a way to make this dark mode. Have my plugin installed? I do not. I do not. Okay. That's fine. We'll just be blind together. Just be blind together. I do want to see you. Hello. Okay, so DAW setup Reaper. I do want to know just how to get audio in here. Which should be under effects for its own thing. DAW setup. I think it has like one singular, yeah, here. You do the ADC Plugdata effects as an audio effects, ADC object to receive audio from your DAW. Okay, yeah, cool. We are on the right track, people. So ADC, we want the signal from the ADC to go into our low pass. We have two signals. So what I would like to do is I would like to abstract this to its own little tool so we can do stereo, but I'm not too familiar with doing that yet. Maybe we should just do it the old-fashioned way that I've seen people do this, because this should be channel 2. Signal input from sound card, signal input from sound card, and then somehow we should be able to see what that is. Remember, you can like click on a thing, and then it will show you that thing in the inspector. Don't remember how. That's our frequency. That's going to be the order of the filter, which means the order should be the same as the pole setting. Order and pole are like interchangeable most of the time. So that's how that works. Oh, I should actually just tell people we're actually live now. Share, copy, pasty. We're live. Probably gonna annoy so many people on Twitter. I'm sorry, people of Twitter. All right, so we have our ADC, which comes in. This is our audio input. Should be in theory. I do wonder if it shows you signal change over time. I don't think it does. Maybe it will. I'm pretty used to the patcher setup for this kind of thing. So let's do DAC. So we go out to our, actually, let's do stereo out. Is that the method that they use here? Yes, they use out. Okay, so we can go in goes in, out goes out, and then this should be our left, and this should be our right. And then we will need 2 number boxes, I think. So let's do float. I'm gonna just make it really big. I don't really care too much. We are gonna change these a little bit later. Just like that, and then just like that. I do think that this does send a bang as soon as we set the number. Maybe. Maybe it does. Maybe it doesn't. To test this, though, I'm going to mute the track because I don't want to actually hear anything, because I am very afraid of blasting my ears with this tool, as many people have done before. We are not getting any output. That is because the DSP is currently off. And we can set this to maximum. This should be working. It is working. We have a low pass filter. Can we change the frequency of it? We can. It does not update immediately because we're using float values, like this float value here. But yeah, so you can see on this diagram that we have our first pole. That is going to be if we enable our phase over here, and we suggest because there's some latency. Why are you doing that? That's not normally. It should look something like a normal thing. Why are you doing this? Hello. Should I give you a high pass instead? So we can test that. Cancel. Yeah, weird. Because like what it is supposed to look like, what I'm used to seeing for this kind of like high pass, low pass type thing, is if we open ProQ, doesn't matter which one, then we should be seeing for 12. Why? Why is this so weird right now? Hello? I'm on zero latency mode. Because this looks right. Yeah, weird. Why is it doing this? Let's use Reaper EQ. Ria EQ. Hello, Ria EQ. I haven't seen you in a very long time. Yeah, this is what I kind of expected to see. This downward slope. Excuse me. Just getting into like the lower range over there. We flatten this out. We should see this shape, this S shape. Except if we switch this to low pass and then set the bandwidth to more. No, I don't actually think you have that. Do we have re-EQ? R-E-E. R-E-E-Q. Re-EQ. We put re-EQ over here. Yeah, this is sort of what I was expecting to see. Your lowest is 12? Oh, it's 6. Why? Why is it doing this shenanigans? I'm thoroughly confused. Huh. Yeah, weird. I don't get why it's... Was it always like this? Was it not always like this? I always remember it like doing one singular one of these. No, I'm thinking of all pass filters. When you do low pass, and looking at the pass band. Okay, I mean the stop band. It has been a time. Please do excuse. Yeah. So let's do this. It's fine. We should be actually getting the right shape for this. If we do 1, and it's not updating. Hello? Oh, DSP is off again. That's a mute button. Oh, this is the actual mute button. This is DSP going on and off. Okay. Okay, so I am still confused as to why this is happening. If we... Ooh, don't do that. Ooh, okay. Yeah, this works. I think I need to make you bigger. Oh. Oh, interesting. You can put negative frequencies in here. That's bizarre. I don't know what that will do. Looks scary on the phase though. Wee. I think it's just because it becomes silence. It's like trying to show the phase for it. Does this allow you to go like really sharp? Oh, it does. Oh, that's awesome. Oh, but it does freak out a little bit if you go above a certain range. Fascinating. Yeah, anyway. So we should be able to see if we set this at a... Can I type in here? Oh. You go back. I don't think this is the tool to do what I want to do, but this is fine. So that's 100 hertz. We go here. And this should be our stop band position for the phase. But why aren't you what I expect you to be? Yeah. We got a 2. We got a 1. Go to 1. I really did wish. I wish he did not make me do this. Huh. We don't get 1 pole? We not get 1 pole? Did I mess this up? If I do that. Yeah. Okay, but yeah, look. Like, we're not supposed to be getting any phase change on this. So if we do this, okay, 64. So by default, you have 64 samples of latency, which is also unreported. Why? Well, it does report it here, though. These don't see it. Maybe I need to actually do inter plugin. Latency, which is over here. PDC mode per plugin, the old way. I think this should fix our phase from being the way that it is. Hello? Yeah? No? Hello? Yeah, okay, so no. Now it's 256. Great stuff. Great stuff. We just made it much worse. Per chain is fine with me. Why are you 256 now? Why are you 256 now? Okay. Okay, yeah. Great. Okay. Fine. It's fine. We'll just know we have 64 samples of latency. It's fine. I may interact with you still? Yes. Okay. Okay, here we go. So let's do this. We go low PF or LOP, I think it was. 1 pole low pass filter. I do want to see just real quick this one. Hello? Oh, right. I need to give you a roll-off frequency, which is cutoff frequency. Yeah, sort of. No, yes, this is correct. I believe? I think? I don't remember. I feel like I've forgotten everything at this point. That's not good. I'm gonna remove you entirely. It's just, we can undo to get back to it. I just really want to like, I want to know. 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 Do I have engineer's filter installed? I don't. Do I have DDMF's EQ installed? DDMF, I have plugin doctor. That's not going to help us in this situation. Gosh. Do we have a Butterworth filter? We have a 4-pole. Also there was a minimum phase one there we could try. Oh, but this also does, yeah, see, that's what I was expecting to see. But this is a 4-pole, so that does mean it's 24? But still, it does not look like that. You know? This is what I was expecting to see. Is some type of change like this, but not, because I do believe we can just go in here and well, actually no, because they're doing the coefficients by a manual amount. Okay, that's fine. Let's see the other Butterworth real quick. Butterworth. Frequency splitter should be fine. Slope of 6. Slope of 6. Yeah. Oh, wait. Volcano? Volcano. Maybe. No high quality mode. Yeah. Yes, thank you. This is what I was expecting to see. Okay, so this is a 12 dB per octave filter. We should be getting 180 degrees phase change in the negative direction. So that means that low frequencies are later by 180 degrees per cycle for each frequency thing. Yeah, okay. This is what I was expecting to see. If we have 6, it should be half. It should be this. This is what we should be seeing inside of Plugdata. So if we go back now, we didn't do too much. I think we can just step back like this. We survive? It survived! Okay, so this is supposed to be a 1-pole, right? That's what you said? That's what you told me, 1-pole low-pass filter. Yes. Then if we change the frequency, set our volume to max, we should be seeing half, right? Like it should be going to half point here, but it's not. Is it because it's actually doing something in the background? I do know that it does have a safety of some kind turned on by default. It used to be down here as a shield. I don't know where it is anymore. Yeah, this is a little bit cringe. Why are you the way that you are? I expect you to go down here for a 90-degree rotation, but you're not. What do we do? What do we do? What do we do? What do we do? Do. Can I go into the settings? Does it have oversampling by default? Latency samples. No, I don't really want to do that. Paths are fine. This is fine. This is fine. Oh, it does say 64 now. Okay. Okay, why? And whyest does thou change? When I hath not done anything? Why? Why? How strange. Yeah, because here's our dry signal. This should have no rotation. And it does. Like all respect, it does do this. It does compensate for it. Look, it just compensated for. Well, it didn't compensate for the phase change on in total. Yeah, what is this? Is there? Do you have a DC filter somewhere? Just at like the lowest of the low. I can't even go down to check. It does seem that way. You like turn this off, you can see the dip on the linear. Is that all frustrating? How do we figure this out? I desire to know. I desire to have the knowledge. I think we should let's do a knob. I want to set a range for this knob. I think I will do that with math. We will multiply you. Well, do we? Huh. Yeah, I don't know. I'm still thinking about like how to fix this so we actually see the filter shape, because that's crucial for me to figure out what's going on. I'm gonna type filter. Generic filter module. Let me know the way. We have Hilbert transform. That's gonna be very handy, because that is one of the things I want to actually do in a later tool. First order low pass, we did LOP just without any extra. One pole low pass filter. LOP 2, first order low pass filter. One pole low pass filter. Am I wrong? Is one pole a 12 and first order a 6? Is that how this works? Hello? Hello? Wikipedia. I don't know if I can pull Wikipedia on the stream. I have no idea. Also, what the frick is this page? Wikipedia. 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 Yeah. I am not braining right now because I'm confused. Wikipedia, one pole, low pass. Low pads. Yeah, whatever. Let's just search one path. Like, well, here, actually. This is an RC filter. Give me dark mode. I have my eyes. Yeah, tell me. One pole. One pole is a -3 decline. Yeah, at that position, yes. But then from there to there, for an octave, -20 per decade? Per decade? Why decade? I do not know of the decades. I only know of the hertz. Unless decade is supposed to mean octave. Per octave. But that's not... For one pole? Really? No, I don't remember that being that way. Hello? I'm not gonna... My child instinct is being like, go chat GPT it, just to know, but don't want to. I don't want to do that. Yeah, look. -6 dB per octave for every octave. What the frick are you measuring at, though? Because this is 3K. That's 3. Are you going up to, like... No. But yes, this 0.07 is importante. It is square root of 2. I believe. Some square root of 4 or something. I'm gonna type 1 pole Butterworth. If I can type. My brain is not braining. 1 pole Butterworth. I would like to see your diagram. What is a Butterworth filter? Ideal response. Flat. An order of filter. An order. Yeah, I need to get one of the classic diagrams that are not these diagrams. Can I do... Oh, and we're full screen all of a sudden. Why are we on this page? Let's just go to my friend, the Google. The Google. The Google. Take me to the Google. Take me to the filter. Take me to the image of the filter. Take me to the image I desire to see. What a... Yeah, this is the one from Wikipedia. I think. Because also 20 per decade. No, not the exact same. But it is also 20 per decade. I need to figure out what this decade system is. Or metric? Whatever. Yeah, this is the one from Wikipedia. This one, 3dB roll off decade. No. Anyway, it should be -6, right? So if we do, I'm gonna make another track so we can keep track of this on Volcano. Because Volcano do the thing that we need to analyze. And the reason that I want to do this is I want to be sure that every time I put something through something else, that I know what the processing is doing. And sure, you know, I could just flat out render a thing for it, but I don't really want to. I do want to be able to analyze with tools that I already kind of know how to use as a reference, a mental reference point. Why are you now all screwy? Hello? Oh, because high quality mode. My bad, you have oversampling. I understand. Yeah. 6, -9. -90. Nibbidi-bab. Nibbidi-bab. Okay, you, go in there, go in there. You need a frequency. I need you to not be changed like that, because I don't like changing this number to the thing that we need to change it to generally. Nicer to... No, actually, you know what? Because of finickiness, it might actually be nice to do this. But I need to set this range actually with, can I do that? Sets and outputs a value? No. I need to set your value based on sample rate, actually. That would be ideal. That's okay. Let's just do like very rudimentary 20,000 value there, 10,000 value here. I mean 10 value here. Our increment number, do we do that? Can we do that? Initial value, angular change, 270 is fine. That's that rotation. Log mode, yes, please. Log mode, because we're doing frequency changing here. That's the wrong shortcut. Yeah, so this works. And now it is 90 degrees. The phase change. Because LOP2, maybe? LOP1? Does LOP1 just have an extra sample or something? Or like half sample? Please. Thank you. Do you have half a sample or something going on? What is this? What is this shenanigans? Did I open you all the way? Yeah, what is this shenanigans? What is happening here? Why do we have a half a sample? Can we analyze this? Can I tell me? Compo was specified cutoff, like roll off frequency. Left inlet is the incoming audio signal. Yep. The inlet is the cutoff frequency. The right inlet is the cutoff frequency in cycles per second and can take a signal or float. If a float is given, as in the example below, a slightly faster algorithm is used. Oh. A float is given in the example below. I assume it's this value that they're giving. I don't want noise per se, but that's fine. I understand. But that means that that actually does just have one extra sample of latency. Does that mean that these Butterworth filters are not? Is this not what we want to do? In out. Give me my cutoff. And then how do I do a number box that actually does good number? I need to be sponsored by Good Number. Freaking. Dude, this number box. This is, I think, what we did. I think float. No, number box is different. Number box. Can I set your minimum maximum? I can't. Okay, so 0 is your minimum. 2 is your maximum. Oh, but it does float. Oh, but it does do what I expected it to do in the very first place. We are getting somewhere. But why only a 2? Why only a 2? Hello? From second order to 100th order. Okay, but that's not what I need you to do, though. I do need you to be a 6th order low pass. Okay, so that means we are just going to be using LOP2, I guess. I trust LOP2. I choose you, LOP2. Except I can't change your order. So that is actually a little bit of a problem. You know what? Let's do this for version 1 of this filter, and then we can kind of move on. Is my initial instinct of like being like, is it worth like diving deeper? Can we just get like a list of filters? Is that something we can do? PD list of filters. Can I do Plugdata? We're an hour in. Like 55 minutes in, and we still are just dabbling with filters. This is crazy. I would like to know. I would like to know things. Can you let me know things? You know. Filter. Type filter. just read through here. I would like to know things. Filtered delay, that's fine. That is for more musical kind of patch setups. I'm gonna make you just a finesse amount of bigger. I sure can't read. I know many people probably cannot read that. And I myself would like to read. It did not change diddly anything. Themes. Can I change your size? Advanced. Can I change your size? 100? 150. Bada bing. Bigger. Oh, I can read. It's fantastic. Okay. One pole low pass filter. We've been over this multiple times. Brick wall filter, very cool to have in this. I do actually want to take a gander at this just for like another project. Oh, it's very good. Oh, it's very nice, actually. Oh, it's a very nice. Oh, it's a very nice. Look at this nice single rotation from where the cutoff is all the way around. Very cool. If this latency is to be trusted. I don't. Can we get some more information? You tell me what you are. 60 dB per octave. 10th order Butterworth. Okay. But then in that case, why? Can I undo? Can I reshow? No. I don't know what the shortcut is. Butter. Butter. We want butter. Butter. Buffer. Router. Buffer. Get set array buffer. I know about those. A little bit. Okay, so man, that's fascinating. I do wonder why they chose to design it this way with only from second order up. This is default Hertz value. This is default order value. And that's going to happen every time you set up. Why is this else? Oh, because this is from the else library. Okay, that makes sense. Oh, we can also do biquad. Biquad is also a thing we could try. But to do this, you need to know coefficients, and I'm very afraid of coefficients. I have a vague idea of what coefficients should be doing. I have no idea how to get there, though. Yeah, biquad series. It's a 2-pole filter. Do we have a single pole biquad? Do you get that? I'm pressing Alt 1 to open the thing. Yeah, I really needed to not open to this page. Okay. I'm just gonna Oh. How does this help anyone? Oh. Yeah, because you list the 5 coefficients. I see. I assume you can plug something into the same node and then pipe in the, yeah. You can pipe in the coefficients into this first node. It also takes the audio. Yeah, it automatically like filters them for that. Okay, that's very cool. Now, do I know how to do any of this? No. Not even a little bit. But that's fine. Well, we'll get there someday. Okay, so I'm thinking we do this. We make just our first plugin with just a single 6 dB per octave filter. And then we can scale up from there. We just need something for our first little project. And I am more concerned about getting the automation set up. and then also being able to get some interface stuff just sort of going. We don't need that anymore. We just have like a simple little Hertz control value, which is logarithmic. And let me go on a little side thing. So the way that we have values here is we have either linear. I'm going to switch from pink. We either have stuff in linear, or let's do it like this. We have 3 domains, right? That things can be in. Hey, Vin. Heck yeah, it's going good. We're figuring things out, sort of. Welcome to the stream. Heck yeah. So, yeah. We have 3 domains. We have linear. This, which just is literally between 2 points, first point being 0, second point being 1, just a straight line. Every value input is every value output. So if this is like 0.5, then over here, our output value will also be 0.5 over here. 0.5. Both of these will correspond to this value over here. Our second domain that we can have is a logarithmic domain, which is super common, which literally just takes this guy and then puts it into a log function, which just turns it into a shape like this, essentially. So if a value is 0 and a value is 1, then this will do an upward shape like that. There's a lot more that goes into this. The values actually do change, but a value between 0 and 1 does just kind of like get this curve somewhat. So a value of 0.5, I don't know this off the top of my head. I do wish I do. You can probably look in Desmos and figure it out. But a value between 0 and 1. If we have 0.5, we have some like really small value. I think it's going to be, actually, it's going to be -6. Because this is equivalent to, well, is it? Because it's from 0, usually for the other calculation. Also, I think I'm wrong. I think this is an exponential, actually. Yeah, discard that. It's actually going to be this. Let's go look. I wanna like just talking my ass. Desmos. Oof. Open. Why live? What is live Desmos? No. Yeah, okay, so if we have a value of x is just linear, where we have 0 and 1, then if we put x through a log function, just go log x. Yeah, okay, I was wrong. So we have that. If we do -1, I believe, on the outside. No, on the inside. Yes, but positive. We get that. And if we get to the value of 1, then that's a value of 9. Okay, yeah, whatever. I have not. Just not. I'm not braining. Yes, I was exponential. Yeah, I don't know how to actually do this very good. I just know that this is the shape that you would get. So if you did actually make this follow from 0 to 1, then it will do an upwards curve like that. I didn't know it from my heart, but now we do. So if we have log of x and we somehow map this to be 0, and we somehow map this to be 1, then it will look like this. If we have our third domain, though, and this actually does do what we wanted to do, then we have our exponential. This is logarithmic. This is exponential. Yep. So what this would look like is if we have a 0 and 1, and all of these stem from this this linear setup, by the way, then we would have a shape that looks like this. So if we design our controls for anything, then we need to actually map it to that. Otherwise, this is going to feel really weird. So if we set this to just linear again, then you'll see like if I go to halfway, then it's just like even nothing. It's just like way up here still. Where you need to go really far down before you actually get to like halfway. And this is like not usable at this point anymore. So that's why we set this to logarithmic. Frequency is logarithmic. It does that like exponential climb really fast to 100, and then gets really fast to 1K, and then gets really fast to, well, it slows down like over time. So the further it gets up, the slower it gets on the one side. Yeah, that's all. That's all for this thing. So yeah, so for the rest of the HLP, we'll need to do a high pass as well. And then also what I would like to do is I would like to bypass this as soon as we get to 0. Well, for the high pass, as soon as we get to maximum, it should do nothing, which it seems it does do that for you to some degree. We will need to null test this probably, but can we? Because it has some arbitrary sample amount that it does. Maybe we can't do that. I'm not sure. Anyway, we can do hip, and hopefully there's a 2 version of this. Let's plop it in there and see. I don't know if there's a shortcut to disconnect things easier. Probably not. I'm just gonna do that. These won't be doing anything for a little bit. You go in there, you go in there. Yeah. And then we duplicate you. And then we need you to go from 0. Okay, yeah, so it does actually keep the filter on for this one. I don't know about this one. Hello, let me read. 1 pole, 1 0 high pass. I don't know. 1 0? 1 to 0. I don't know. High pass filter with a specified cutoff frequency. The left inlet is the incoming audio. Yep, that we know. The right inlet audio, the right inlet sets cutoff frequency at the control rate only. Okay, yeah, that's good to know. That means we can't do sample rate automation for this kind of thing. So we can't like drive this filter with another oscillator from the outside using like a sidechain out like input from the DAW. I tried to get a grip on Plugdata at the beginning of this year, but lost interest too early. Guess I'll have to open it back up and learn. Heck yeah. Yeah. Yeah, I did the same. I was like, I went in. One of my friends made like a really cool distortion. I learned like a bunch of math stuff from that experience of my friend making a distortion. I was like, oh, this is awesome. And then I proceeded to try to make something, and I was like, oh, well, I do know that this is going to be the same as Maxim SP when I tried to learn that the first time. Yeah. Yeah, you just need to like keep at it. I think like you'll pick up stuff as you go. That's been the experience so far. Just like noodle around, figure out what like normal audio parameter setups are, and then use that to control other things. I like how it scales though. Like and all of this knowledge can scale over to actually making hardware instruments and stuff. It's very cool. I do wonder if this works. I don't suppose this will. Yeah, because I won't have any idea where to go. Right. That makes sense. Or it'll just be mono. yeah, I recommend just like maybe picking up a single thing. That's what I'm trying at least. Yeah. Here's our like setup for making this. The light shard, high and low pass, which is also made with friend Saber. Eh, 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 eh. Friend Saber. I'll keep friend Saber here. Friend. Point. Yep. Yeah, we made this in live at one point, and then we kept using it, but it wasn't just like a 6 dB per octave filter. You could switch between the different like poles or orders or cutoff like sharpnesses. And it was really handy. We still kind of made a samey thing in other things. So we made one in Snap Heap that we use a ton. I think I have it here. HOP 0.2. Yeah, this guy. So you can see the mix turns off as soon as it gets to the minimum. We high pass up. It's not oversampled in Snap Heap, which is a little sad. That's fine. Yeah, so this is the goal. We're just making this again as a starting point to kind of learn how everything works. I like this. I like this having a goal to actually do something. I always just kind of noodle until I figure things out. Uh-oh. That's not pleasant at all. Oh. Oh, that's a problem. That's a little bit of a problem. Yeah. Can I fix you if I do that? No. It's in the void, people. What happened? Can I reset your size somehow? Oh, interesting. No way. My problem is I can write something from scratch or tinker in the DAW with knobs and sliders, but somehow trying PD or Plugdata didn't really uh, made sense in my brain. Yeah, I can see that. That makes sense. Yeah, yeah. I just need to kind of noodle with it. It's the same as programming, in my opinion. It's just more visual. Yeah. Hey, Hyperlus. Hello. Yo. What's going on? How are we gonna fix this? This is bad. Maybe we can save and then we close both of the patches and just open a new Plugdata patch. See, this is the kind of thing where I'm like, in actuality, why does it do that? Oh no. Oh no, it's very stuck. It's very dumb. Hello. I would like to have my interface back so I can actually do things on you. We might need to close Reaper and reopen it. Plugdata. Plugdata. Let me do things, man. Mute. We don't need to listen to it. Heck yeah. Yeah, welcome. Oh gosh. Oh gosh, it's really screwed. Oh, now it just went somewhere. Yeah, that's not great. How do I resize this at all now? I guess I don't. Ah, here's our parameters. Good to know. So they're all just by default disabled. Okay, that makes sense. Okay, well, that is actually a big problem, though. How do we get how do we get it to not do this? Maybe I can open another DAW and it will not freak out. FL is pretty good in window handling. Doing all right. Was curious about learning about Plugdata. Heck yeah. Yeah, we're noodling. We're figuring it out. I'll explain some stuff real quick if I can get this to not be the weird size that it is. Why is it doing this? Thank you. Now if we resize any of this window, then it should just update. Yes, thank you, Reaper, for being very strange. I guess we'll do Plugdata stuff in here and just unroute. I do enjoy FL's updating of window sizing. This is something I do wish that Reaper was better at. Oh, hello? Oh, gosh. Oh, gosh. Okay. It's fine. Okay, well, we're back. Let's throw some EQ analyzers on here again. EQ analyzer. I did it the wrong way around. Click this button. Oh, it's gonna really just freak out, huh? Huh. That's what I get for using the nightly. But I do need to use the nightly because it was freaking out when I was using the normal one as well. Which was strange. Okay, so here we go. This is what's happening. This is where we are. I'm gonna just like recap up to where we are right now. Control T to get a new page. Yeah, great stuff. Okay, this is where we're at right now. So with Plugdata, Plugdata is very cool because it is a visual programming language. I do think that is how they refer to it generally. But it is a visual programming language made for musicians. Yes, I do think that's how they market it. So it is made for musicians in the way that you can take little code blocks and essentially just connect them together in a string. And people have been doing this for like a very long time. This is the same as making schematics for like actual hardware. Like if you get into engineering a little bit, which I just kind of like studied on the side. I don't have any like papers or anything for this kind of stuff. I just like am very interested in everything. If you go into engineering, then you will see that you generally have like a big pipeline of just lines and components. And those components are either parallel, like this, or they are in series, where items are immediately like after each other. Most of us learned this in like school for like how electricity works when you do science. If you had science in school, kind of depends on what you studied, I guess. So Plugdata is kind of this idea of this, where you take components and you just string them together, and it makes either an effect, or it makes a synth, or anything that you really want. And you can do interface design for stuff, so you can like have knobs, or you can have like a square, and then that's a slider with a little handlebar that goes either up or down. It is very cool. You can do very advanced stuff. You can even have this be an image. So you go into like Blender and you render like different knob motions, and you just render like a bunch of images that are just all the positions of the knob, which generally is 127. Well, actually 128, because computers start at 0. So you have 128 images. You just tell Plugdata to flip between those images when you get to those values. Not particularly difficult to do. Just like getting started with this is like, oh, that's very weird that we do that, but it kind of makes sense, right? That we have like values that we just say, okay, choose this image, and then it puts it there, and it puts it here, and it puts it here. For every time you like move the knob, because it is essentially just telling you a value. You're like, hey, what's the value? Show me a visual representation of whatever the value is that I set a knob to. Yeah, so that's that system. And same with sliders. Sliders are just a bunch of images that either get generated or you generate yourself by using a program. So either math or other math that you turn into referencing data math for screen. Yeah. So GUI. For the backend, though, you have a thing called DSP, which is your digital signal processing. And what this does is actually the brains of the whole operation. So that is this section where you have an input and you have an output. And that's kind of the only thing you need to know about this segment. Everything that you put in between is going to be a little like study session. So for me, I like wanted to do this really basically, where I have done a lot of this input output shenanigans with like other programs, and gotten like pretty in depth with like doing a bunch of parallel stuff and the diagram designs like this. You can look on Twitter, like if you search. Well, actually, what do you search? I don't remember if I used a search like a specific word for things, but I do have some images of diagrams where I just by hand drew the diagrams out and like the certain blocks of processing that it does. And Plugdata is exactly this. It is exactly the idea of you take an input, which is just your signal, and you do some arbitrary processing to that signal, either make it a square or something, and then you just feed that back out in your output stage. Yeah. How you control these values, though, is all this GUI shenanigans and math. But it's chill. You don't need to know too much to get into it. Other than I would definitely recommend at least knowing the 3 domains that are generally used. This is not the right terminology, by the way. This is just my terminology for referring to this stuff. You have linear, you have log, you have exponential. And all your controls will be one of these. Some variant of this, some little deviation of this, like either it's log or it's natural log or it's exponential or it's cubic. It's like all of this stuff is in there. And me, I failed math. So I am in the deep weeds and I need to learn everything from scratch to really get into this again. Yeah. So for this setup, what I like to do is I like to just throw up some analyzer that I'm really familiar with, and then throw up our diagrams for what we're actually doing. And this is a good reference always, because then you always know what's kind of happening under the hood. Like for instance, if we didn't know that there's 64 samples of latency being processed right now for just having this high pass in here or having these low passes in here, then this diagram tells us, oh, well, by the way, this plugin always has 64 samples of latency, which we can see if we hover over it in the DAW. But we wouldn't have known had we not had a small visual representation to kind of look at that and diagnose things. So I always feel like having some way of diagnosing what is happening under the hood is very good to have at all times. Which is why I like having this at all times. Yeah. Yeah, this should be kind of good to go for our first thing. We can kind of plop this in there now. What I wanted to see with this initially is like, this is our high pass. It's just high and then P for pass. And then this is a signal. Any square that has this symbol has to do with signal. So if you can like do math with this as well, you do like that and then a other way around, I think. That. Yeah, there we go. So this is a multiplication operator for signals. So you can put a signal in, you do some kind of math value over here, and then it spits a value out at the bottom. but with two signals. So if you have one signal go in, and then signal goes out on the outside. I do think you can put normal values in here. Let's see. The alt click, you can go into this window, which is scary for some of this stuff because it's just like a ton of information. But it is just essentially F1 for like most DAWs or programs. It just tells you like, hey, what does this thing actually do? And then they describe a bunch of information. Maybe a little too much sometimes, but it does get you the initial. Yeah, so see, like this is all the operators. This is adding. This is subtracting. This is multiplication, division. We can grab the maximum, which is technically the minimum in most cases. We can get the minimum, which is technically the maximum in most cases. This has always been weird to me. This max min, all of math flipped. Max is min, min is max. Sort of. Yeah. And then here's our logarithmic, which we did for the control. Here is power of, which is our exponential, which we now know looks like this. So we can also have x to the power of something. Can we do power of x? Makes sense? No, because it's a changing value. Just 2. Let's do parabola. Yeah, it works. Oh my gosh, I cannot control scroll on this website. That's not a good idea. Just normal scroll. Yeah, you can kind of see these diagrams here. So we have 0, 1 for the exponential. I don't know how to do the logarithmic in this range. I do know that there is a way to do this. I don't know how though. Maybe it's something like divide by x. No. Divide by log. That's just gonna probably not do anything. Yeah, it's value 1. I am silly and dumb with this. I will learn. I will ask my good friend, Mr. Hikerus. Hikerus, tell me the math. Teach me the error of my ways. Okay. But yeah, so this is basically it. This is all the math that we can do with any operation. Obviously, these are signal ones. You also get ones that are just normal. So I just have normal linear x, linear log x. Let's see. Well, it does go to 1, but we need to go through 0 and 1. And I'm still gonna control scroll because I'm so used to other programs. Wow. Can we just log through 0 and 1? We search that. Hello. It's always positive and lies between 0 and 1. Log table. No functions. Log, but between 0 and 1. No. Yeah, close enough. Yes, I like it. Yeah, the only difference between normal log and linear log, as far as I know, is the base. So I think you do like log 1,2 for like some programs. Like FL does this for the patcher. You can do or like their formula controller. Formula controller. Can we just put it on here? We can. Yeah, so it has log. So you can do log of A, and then you get same control value data as what we're doing in here. But you can also do log of A, and then go to the help section, which is my other browser. Then we can do log with a different base. Where are you? Yeah, this log n logarithm is a is a base, b is the number to calculate from. Yeah, so this is just the system. Either you're log 10, linear log, which is base e, which e is a value. One of my friends was like, e is a value? And yeah, e is Euler's number, or Euler's number. So that's all that means. The base, the part here at the end, becomes sub whatever base value. Yes, sir. Anyway, sidetrack, big sidetrack. But yeah, that's all this. You get math operations that you can do, which are also the same as the other one. It's just plus, minus, multiplication, division, max, min, log, pow, which is exponential. Yep, and that's that. It's not too complicated stuff. It's just like getting used to this kind of stuff is weird at first. For me, it was very strange when I started figuring this stuff out. I sat for a very long time just looking at diagrams and people just going, "Oh, this is what this is." Yeah. Yeah. So thing about this is halfway between this positive phase rotation and the nominal value or unity is where our cutoff is. So if we set this to just some like value that crosses this line, then this should be our cutoff frequency, which is -3, which does mean that is probably some kind of Butterworth. Filter. Probably not. You know, we figure it out as we go. So this guy, we need to disconnect this. Yeah, okay, that. Click off. Give me your value. Yeah, you go in there. You go in there. We need to set these so that they don't do anything. And then we also need to make them go off. Now, to make stuff actually turn off, there was a certain node that you use to actually do that. I don't actually remember what it was. I'm going to go to my history real quick and check. Plugdata, turn off DSP. Switch. It was the switch. Yep. Okay, so we have switch like that, and this is a signal switch. Now, is this what we want? Switch or block object without arguments does not reblock audio computation. In other words, oh. This is not what we actually want. Well, yeah, no. Unless you set a single step DSP, okay. This is just an example of switch. That's fine. Let's go look again. I'm just gonna search further. Plugdata DSP $1, which is just some parameter value. Turn on DSP. No. You are not missing anything on the second screen. It is literally just me going up and down on Google. Enable, disable subpatches. No, we're fine. It's fine. You know what? We're just gonna do a normal bypass. I'm gonna do a very jank bypass, which I've done in other things, but the audio is still going to be rendered. This is gonna be the worst way to probably do this, but it's gonna be some equivalent of actually doing this process. So how we're going to do this is we need to make this filter out a value. So whenever we have a value, we're going to do it like this. I'm still going to press Control. We're going to do it like this. So this is x, our red value. If we have a max value of x, and that max value, I don't remember how you use this operator actually on here, just for the second thing. Do you do comma? You do comma. Okay, it is the same. Yeah, okay, so you can see what's happening. We are flooring all of this value. Like any value that is 1, like below 1, floor. This is why I said that max is always the minimum value. If we set this to a value of a parameter, then if we set this to 0 and 1, which is the only values that we're working with, then you can see that whenever a value reaches the value of what our knob is, this is just a knob, then it will just hold that value and just be that forever. Now we actually want the inverse of this, I think, because we always want this value to be 1 when it actually gets somewhere. Because currently our knob goes between a value of 0, or 10 and 20,000. So whenever this value, whenever we get a value of like x, which I'll change to b, we can set this to be the same. I don't know why I do this, but you can hear that every time I make a variable, it is like a variable, and it will be. Anyway, if we set this value of b, then our value will always be 1 above whatever this value is. So if we set this value to be frigging, wait, hold on. Okay, it will always be our second value, actually. We flip these around. Hold on, chat. Then nothing will change. Smile. Of course. Wait, no, because we're taking the minimum. Ah. We will get there. We will get there. Basically, what we want to do is when the value is 10, if the value is 10, we can do an if operation if we want to. Can we? I think we can. Essentially, what we want to do is we want to do some logic. So we say if our value is smaller than 11. So if a is smaller than 11, then we should get 1. Right? So if that, then this thing. Programmatically. This is what we need to do. So what we could do is we could divide this value by 20,000 and get 0 to 1. That's not going to be fun, though, because it needs to do that every time. So actually just doing if the value is bigger than 10. Can we do if operations in here? If I do this, and I do that. Yeah, we can. Okay, great. Yeah, so if we do, if our value is, oh, but how do we input a value? Is that $1? Simple in, 1 out reverberator? What? You know what? I actually don't know how to do this. Do P1? Yeah, and it just freaks out. Let's see if we can figure out parameter. So Plugdata parameter inlet. This is going to give us parameter inlets, which is the DAW. I don't want that. I want to just have a variable inlet. It is very funny to me that we've been streaming for 1 hour and 40 minutes and this is what we have. Sometimes that is how it be. You will get there. It will be good. Thank you, Copilot, for answering my question by not answering my question. Maybe. Inlet, outlet. I do not want that. That is not what I want. I need a variable that I can set. And the Plugdata in, documentation isn't really fleshed out yet. I might need to hop into the peer data documentation. Yeah, let's do that. Peer data, variable. But as an inlet. Because all these on the left are inlets. All these on the bottom are outlets for the controls, input and output. But what we want to do, what I want this to do is if I do this and I say something is bigger than something, then I need these to actually be inlets and outlets, which I don't know what the setup for this is. How do you do? Tell me. Hello? Well, fair. That was a fair response. This is empty. I'm going to do that. Oh, does it just give you? I'm being so silly. Look, it just gives you float set value for the left hand side and trigger output. Float set right hand side. Okay, we just literally need this. Okay. Then we do, if we do right click, or actually up here, we can grab a float value. And we just set this to whatever our value is. Do I need a number box? Do I need an object? 1. Because I need it to bang at the start. The way that works, as soon as this patch loads, then we want it to send a signal that basically just like changes the parameters for us. And bangs are essentially an output message, and they just send a singular signal like one time. The equivalent for this in like the analog domain is the DC offset operation, which good thing we're on FL actually for now, because you have a tool that does that. Cannot remember the name. Voltage. DC. No. Oh, actually, I do think they disabled it in default now for most people, because people were getting beginners were like tripped up, I think, because of it. DC. Volt. Not voltage modular. I really don't remember what it was. Frick. You know. FL people are probably going to scream at me when they watch this video at some point. Especially my friend. What the frick are you doing? What the frick are you doing? You don't remember? We used it. We used it that one time. And we're like, yeah, I know. Streaming makes me nervous, man. Yeah, I don't. Anyway, here. I'll just build it. I'll just build it by hand. And it's going to do painting things, and we're going to make really pretty pictures with wave candy. If we make this asymmetric and we just do that, you can see it's always sending a signal, right? Now, what a bang is that it essentially always has a signal, but it only sends it one time, ever, unless it is triggered. And the way that that looks is like this, where you essentially have, I'm going to do this in the most jank way possible. Going to be a much better way of doing this. But essentially, you have a single, just like, blip of thing, and it will look like a hold. Hold like that. It'll turn on, it'll turn off. It'll always be off. Like, some period on, some period off. But it is actually just like an infinitely small, just single trigger of thing that happens. And that will then look like this, where we turn this off, we turn keyboard mode on, bink, go over here, we select this automation, we can trigger it, then it should. Oh, wait, they changed this? It's not a single thing anymore? Okay. I'm learning even more about FL now. Woohoo. But anyway, it turns on, it turns off. You can see it over here. It just single signal, single signal turns on, turns off. That's what a bang is. Sends information, turns off again. And it only does that one time. And generally only does it the one time when the program starts, depending on the setup that you do. There's a dedicated thing that does a single bang at the start. It's called init, which does an initialization message. Yeah. So if you want to set parameters like immediately at the start, then you would use an init message to do that. But for this, you need a number and not a message. And I do believe they are different. I don't exactly remember how, but I do remember they are different. That's a signal. We need to control. We need to control you. Analysis. What are we going to do? Wrap number range. This is handy. It's handy to know about. My numbox. Number box value. Number box value. Number box value. 0 to 1. Oh. By the way, the reason I needed to go to nightly was because of this. I tried setting a value like this, and changing this parameter and then closing and then opening this interface would reset this. So I had to go to nightly for this to work the way that it does. This should work if we set this to 10, or rather 11. And set this to 11. I don't know how to do normal numbers. Anybody figures it out, chat, help. So if we read this now, we can use the same thing over here to read this value. Then essentially it should be receiving this value that we're changing here, but it's not. Do we need to send this as a bang? Bang! Bang. Except that's probably not how that works, because we need a trigger. Except not that trigger, we need this trigger, toggle. Except not this toggle, this bang. That work? Hello, 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 hello. Smaller than? Hello, 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 hello. No value? Not receive any value? Oh, this might be handy. And drag. Yeah, of course. So this is printing whatever n is for this number box. It is just grabbing this value and printing it. This is like hello world type stuff. Number box is a GUI. GUI that sends numbers. Click on it and drag the output to. Yeah, but that does mean that it immediately changes the number. What is this though? What's this guy? Tell me what you are. Identify yourself. Uh, eh, Aha. The way I did that, by the way, we went out of edit mode. I alt-clicked this, and we get over here. What are you? You have a number box. That's the one with the triangle in the top right. Numbers have connect to the top and bottom connection from. What? Numbers have connect to the top and the bottom connection from the bigger than. Connects to the top of the knob? No, because like if we do that, then it is going to change the value of the knob. So you can see this if I grab this guy and I just do that, and I change the value, now this value changes. This inlet at the top is a receive, so it will immediately change the value of the knob according to what this value is. So you can see, because this is a value between 0, like 10 and 20,000, we're currently at 11. And if we go smaller, I don't think it will actually set that value. It would just literally be this value, which we can also look at like that, I guess. Yeah. Yeah, so we can see that this value is 10, and will only ever be 10 if we change this value. I mean, we could do it with a knob. That's kind of weird, though. We would be probably using extra drawing to do that. Do we do that? Yeah, screw it. We're doing it as the first version. We'll replace this guy. So essentially, this is how this is going to work now, because now we have good power. We have good power over this friend over here right now. I'm just gonna, we ignore these. These don't exist right now. So essentially what we're doing here is we set this value to always be a value of 1 and a value of 0, although we will need to probably do some funny shenanigans. Oh, its an initial value needs to also be 0. Also, it's still freaking out. Why? Why are you freaking out? Because this value is already 10? Yes. Oh, range can't contain a log mode. Yes, that is true. But you're still upset. Why are you still upset? You're silly. You silly goose. You silly goose. You're still upset with me for setting this value to 0. I think it's still upset because look at the knob. What are you doing? What are you doing now? Initial value of 0. Our minimum is 0. Yeah? But we are piping a bigger value into this, and I think that is the cause of this being funny. Oh, no? Now you're fine? What? 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 Hello? Now you just max out at 1, like I wanted you to. This is confusing, man. Why? Why it freak out? And why it not freak out now? Let's do if our value is bigger than 1. Well, if our value is bigger than 1, and we just do that? No. Because I don't want to pipe in a silly value onto the left, but we're gonna have to. I would have loved to just do like value bigger than 1, A, and then press enter, and then A would be our pipeable value, which probably is going to be a freaking thing of not doing that right now. It's fine. Let's see if we can get a numbox for this. Numbox, not numbox, because numbox is signal. We don't want signal. Number a float box, but we actually want an int. We get an int, an integer. Truncate floats and store an integer. Yeah, that's an operation though. I don't want to do another operation. Fine. Fine, I will get a float. Fine, we will get a float. We actually just want a number. My numbox, number box. See also our friend. The number atom box, the symbol atom box, the list box. What's a symbol? Okay. Okay. Okay, but actually. This is equal. Do we get an equal type of this? Yes, we do. Bigger or equal than. Is that what we want logically though? We will need to test because I am not sure anymore. U value. Let me type you. Or not. So if our value is bigger than 10 or equal to, our value is 1. It's 11. It's off. But hey, I do need you to turn on. Is it because we're doing an equal operation? Probably. No. Is it not? It's not sending this information? Or is it not doing the operation as soon as we change this value? Should we flip this? Should it be that whenever this value, you, go in there, you, go in there. It'll be jank. Probably gonna work. 11. Yeah, okay, so now if the knob changes, anything above, it goes to 1. Hip, hip, hooray. We actually want the inverse of this. Hip, hip, hooray. Except it will never be true. Hip, hip, hurrah. Okay, so what is happening here? The reason that I did this is that if you hover your mouse over here, you can see that this receives the trigger, which is also the bang. Now, my hunch here is that we are not changing this value. This will always be 11, or whatever our operation is going to be, just to get this value to be 1. There is such a much better way of doing this. I am just absolutely fried and do not know. I am not aware, which is why we're doing this. To learn. I also just, by the way, I think you can do something where you do script. And then you can actually just write your formula. Formula? No? No, I don't remember. Math. Let me do math. Anyway, what we are doing here, every time this knob changes, it sends a bang. This bang then updates this knob. You can think of it like, hey, CPU, do this calculation when this knob value changes. And this operation goes, hey, I should do this operation right now because, I'm receiving a bang. And then after it gets that bang, it looks at this value and goes, hey, is this value bigger than this value? If it is, I'm going to set this value to 1. And then it sets this knob to 1, which we're kind of just using as like a check to see, like, is it actually this value? But we're also using this as a clamp, which is just the min-max thing that I was showing earlier, where we set this value and then it actually sets the value to whatever we want it to actually be. But I can't math today for some reason. I actually have diagrams with actually does this, and I did actually do this correctly, but today is not a math day, it seems. And that's okay. However, we do need this to work. So when this value is nothing, we essentially want this to be 0 instead of 1. Because what we would like to do is we would like to have inverse values of this, where this operation, when this is nothing, is 1, and then when this operation is 0, another version of this is 0. Because then we send both of these to volume controls. This one controls the volume of the output from the high pass, and then this one controls the value before the high pass, which we'll need to do with an operator, which is like multiply signal. Multiply signal. Oh, can you do control with this? Oh, you can. Yes, okay, cool. So this value, go in here. When this value is 0, we're multiplying signal with 0, that's 0, which means nothing. When this value is 1, we also do this multiplication for this guy. It will then also output. Yep. Boop, boop. But we need to get this to change, because it's not working. Also, I don't think we can do this signal operations thing. This is where things get really iffy for me, because this is switching between domains. This is control data. This is not control data. This is signal. Bum, 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 bum. Ain't this fun? We got to live through the chaos together. Hiya. What is the frick? Can we look at control? Wait, first, let's do this. Let's cover our bases, right? What is this called? Let's get some terminology in here. Because I'm throwing around terminology that is just like general for this kind of stuff. And not the intended, except for this. This is a signal. This, I don't actually precisely know what this is called in Plugdata land or in Pure Data land. So let's first go and get some fundamentals down. Pure Data fundamentals. We're actually just going to do that. Instructables, sure. This is the weirdest website for this to be on, but sure. I'll take it. You have the information, I'll take it. Give me the information. Outlet, inlet. Yep. The basic sense patch. It's fine. This, all audio objects, like audio processing objects in Pure Data, are denoted with a tilde. Yep. For example, a plus object will add together two numbers, as we know, which is audio signals. If you connect a signal to the inlet of a regular plus, the connection will disappear. What? Excuse me? The connection will disappear? Eh? Oh. Oh, yeah, that's true. Okay, good. That makes sense. Now I get it. The most fundamental object in a synth patch is OC. Yeah, okay. We are not doing synth stuff today, so we can skip like ahead. I want to know what the controllers are. Create a slider and an object. Make them together. Why a slider? Why does slider work for this? Why is slider a signal object and not the... Here's what we need to investigate. We have signal, which is our three systems. We have signal over here. We have control, which I don't know what the icon for this. I'm just gonna make like a solid line with like a different color. I don't know. Which is just control. But we need the actual terminology. So terms. And then we have a third guy, which is bang, which I'm just gonna make a star. This is bang. And this is the right terminology. And this is similar to control in a lot of ways. So let's see if there's anything on making an LFO. LFO, pure data. Type domain. Maybe they use the same term. Someone uses the same terminology as me. Smile. It's gonna be unlikely though. Introduction to pure data. Sure, don't mind if I do. Oh, it's a PDF. Go, 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 go. Show me the page. Show me the knowledge. While that's loading, let's do another one. Pure data. Let's just do knob, you know? Because if we just do knob, if we just look at knob, what do we get? Tell me. Pure data receive send param var learn forget. You're just making words up. You're saying words. PD receive send param var learn forget. It's probably gonna be. I think these are like similar things. Oh look, nice interface. ADHD hitting hard. Thank you. Outlets. Knobs value. Thanks, but what the frick type is it? What is this? Where am I? Let's do a slider. Slider is a big fundamental guy. Vertical slider. Tell me. What do we get? Captain. A slider sends numbers via clicking and dragging. These values are evenly spread depending on the slider's range and size. Use a shift click and drag for fine tuning. That's good to know, thank you. By a factor of 100. Oh, nice. Incoming floats set the slider's value and are passed through even if the outside of the slider's range. What? Oh! Incoming floats set the slider's value and are passed through, even if they're outside the slider's range. Ew. Wait, but does the knob also do that then? Because then we can't use it as a range like control, but it does seem to do that. Um. Can I search in this? Range. I don't believe that this is. Oh, it actually is in this interface. That's nice. That's pretty nice, but still don't tell me. Yeah, it does set the lower and upper ranges thing if you use the range inlet. Which means that instead of doing it over here, probably, we should be able to just grab another knob and then actually have a thing that says range, and then in here we say like 0, 1. Does this work? Can you just do that? And do that. Tell me more. Tell me more. What is this? Range. Is that a typo? Analyxes. Analyx is a float inputs range values. Great. Really? Oh, here. Else range. Every time it does this else slash thing, by the way, it is a library. These are actually in here somewhere. They're defined. It's in the paths. Paths. Yeah, these. So you have gen, you have else, you have externals, you have abstractions, you have heavy lib, cyclone, else, which is twice, extra else, abstractions else. And abstractions are when you make your own little like bin for a thing. So what we could do is we could like grab this entire thing and make that an abstraction, and that would be like a thing you can plop in and out of. That's how that works. That is also how you take like this logic. As far as I know, I will need to ask some friends or something about how this actually works. But I think you take this segment, you put that in an abstraction, you reload that as like just a thing. So for me, it would be like an ls something. Oh look, I did this the one time. Yeah, so this, you cannot go in here. Oh, you can go in here. Hey, look, it's the thing. It's the thing we made. I guess it does actually just add them. That's quite interesting. That means if I delete this, I save. Can you do that? HOP. That's nice. I didn't know it does that. Unless I just saved in a really dumb place and it just isn't here. But yeah, this is essentially that. But the cool thing is that if you then have two of them, then you can set this to an inlet and this to an outlet, and then you don't need to do stereo stuff. You just have this and then do inlets and outlets for your controls. And then you just set them all at the same values. That just makes stereo processing simple, because then you don't need to do that for everything. Okay, we still have not learned very much. This is still a number. I guess this is just a float. Okay. That's a float value. We can't do float values with our signals because that would be DC. I want to test this. Can I save this patch? I'm going to just open another friend. Turn off this Plugdata. Let's make a new Plugdata. Plugdata. I would like to test. Hello, Plugdata. New patch, please. I would like an out. In this out, I would like to have a knob. And in this knob, I would like to put the value of 1. Our output is nothing. Do not worry. It will not blast your ears with DC offset. However, I am curious if this actually does something. Oh, it sure as heck does. Oops. Good thing we can't hear that. Yeah, okay. Oh, but is the safety kicked in? I don't know where the safety is anymore. It was a shield icon over here at one point. And you would be able to just protect yourself. Yeah. So that on an oscilloscope. Let's do scope because scope handles DC pretty nicely. Hello, scope. I would like to know things. About. Oh, current. This guy, can you analyze always, please? Even if not playing. Oh. Whoa. Okay. Wait, that's really cool. Any downward motion goes to the negative pole because it's a subtraction. Every positive value is upwards because it is an addition. However, what I do find quite interesting is this this enveloping that it's doing, which I assume is because of some filter. Oh, but it's also not always putting out a bang, right? So send a number of bangs. Can we just always? Can you do DC? DC. Circuit analog circuit. Wave shiver. Huh. How do we do that? Because setting a value of 1 doesn't always output, right? We need a loop. Do you get loops? You have a loop counter. Counts how many times you looped. Phase generator for looping samples. No. Floor function. There's a lookup. Who Who Huh. I am a little bit alone and a little bit afraid. I am not entirely sure how to handle this. How do we do this? Yeah, so what the heck? What the heck? Glad that this does actually show what this value setup is. It is beneficial to know that this is a little bit smoothed. I guess you can interpolate that. How would you? We need to hold on to a value, right? I'm not getting into interpolation right now. Good thing to also know, but I can't do that right now. Yeah, let's back up one step. Again. Huh. Let's grab our num box. Not our float box. Float box. Yeah. Show me the value. Oh, we are setting to 1. We're not setting back to 0. Is this value bigger than you? No. Then why are you 1? Eh. No? Why? Oh, okay. In that case, I will set you to 12 so that you can calculate your value. I think it like skips the value and doesn't actually evaluate it again. Because this definitely is 10 when it gets down, which we can look at if we do that. It's the value of 10. Why, if you're 11, do you not set? Oh, now you do. Hello? Okay, sure. This is what we need, but then we need to multiply our signal with this value. Do you get float to signal? You do. You do get float to signal. So we can float this to a signal. I don't think you need to do this, but I'm going to try it anyway. Multiply by r tilde, which is multiply our signal. And drop this guy right in there. You will be muted. So now we enable our patch. And this should turn into nothing until we do that. Oh, heck yeah. But Chris, but light shot, why is this useful? Well, I'll tell you, fair person who is watching the stream. If we have this, we can essentially multiply this also by value of -1, which we will need to do with a separate box. So we take our value here, because whenever that value changes, we want it to update. We want to have a number, which we'll do with a float. Or will we do it with the same type of box, actually? Give me your box. Give me your box, man. We set this to -1. You go in there. Get evaluate, son. So you, when knob is bigger than 11, or yeah, when knob is bigger than 11, value of 1. Yes, it is true. However, which we use over here. However, when knob is value of 1, make -1. Which we also need a float to signal this. We probably don't, but I'm going to do it anyway. And then we need to evaluate this by just... Yeah, so now this should work. If you are 0, you are not the correct value. Hello? Why? Do I need to use you instead? Fair number box. -1. -1. Change your value. Why? Why are you nothing? Oh. No, 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 no. No, 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 no. No, we don't want it to be a value of -1. We actually just want this to be a value of 1. Yes. We want the inverse of this. It should be 1 minus our input. Go back, 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 go back. It should be subtraction. And then this should be a value of 1. Eh. Yeah, except why is the phase? Why is the phase? Because we're multiplying well. -1. Great! It's sort of working. This needs to flip around, I believe. But however, then we lose our evaluation of the bang. Ooh. 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 Do we just add it? Add a value of 1. Well, we made a shelf. Great job. No. I'm sorry, chat. I failed you. I failed everyone in math. Oh, look. It's still a shelf. Where did we go wrong? Why are you still a shelf? Actually, though, why are you not turning off? You know what? Here. Let's diagnose. You. What the frick value is this? And always why? And for why? And then also, just enlighten me as to this is the value, this is the value. Okay, so we have a value of 1. That's being sent here. We have a value of 1. That's being sent here. That's not what we want because that's going to just output. We want the inverse of this. This needs to be 0 when the thing is not. I'm gonna type this out in actual, just so I can actually brain, because having it out like this is weird. I am not used to seeing this being calculated in the way that it's, so I'm hurting inside now. Okay, here is what we have. We have our knob value. I'm gonna make this big. Get big. Old school. We have our knob value. Our knob value is a value between 10 and 20,000. That's being evaluated. And then we are getting a value between 0 and 1. Then, well, this happens if our value is bigger than 12. Or well, 11, because we switched it back. Remembering from earlier, it's fine. And that's what we got. If our value is bigger than 11, we will get a value of 1. If it is smaller than 11, we will get a value of 0. Very good. Now, what we need to do is we need to take this evaluated value that we have. So we need to say if our value is 1, then make it negative. Just make it 0. However, if our value is 0, then it should be 1. And this is just an if else statement, by the way. So this would actually just be else to value. And this is also just an if else. If this value is bigger than 11, then 1, else 0. Okay, let's just make space. I'm going to put our processing on the other side of this evaluation. So our control data is on the left. My mind hurts, friends. Okay, here we go. Value. Smaller than 11, we get 0. Bigger than 11, we get 1. Let's multiply. Do we multiply them? I don't think we do. I don't remember how to do this exactly. We can do this in stupid FL mode. Bum, 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 bum. My mind thinks in graphs and not in numbers. Okay. I'm gonna open a patcher. I'm gonna build it in the patcher, and we're gonna rebuild it in the Plugdata. Because I know very well how to do this in here. Do, 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 do. Wah, wah, wah. Ha, ha, ha. I'm going crazy. Okay, so I would like a controller. Give me a control map. XYZ. Give me inputs. Give me all of them. Give me outputs. Give me all of them. Okay, here we go. This is what we desire to do. We desire to receive any value between 0 and 1, which in FL is a value between 0% and 100%, which also is just 0 and 1, technically. Our input is linear. Our output will always be a value. So we have a value of 0 or you have a value of 1. Now, this value that we're setting here should be that like 10 hertz thing. And we can do that. We can grab an EQ. Go here, put this guy on here. Go here, put this guy to high pass, like we are. And then what's our lowest value? 20, that's fine. We're just gonna like, the values are gonna be a little bit different, but it's fine. So set this to 20, or actually, yeah, set this to 20. This is gonna be 0. And then whatever value we wanna go to, we set that with the step function, or with the hold. So, which we desire when this value is bigger than whatever value we didn't want to evaluate, which will be, let's do 30. 30 here, copy, paste. Then, well, actually, hold on. Activate you, type A. Yeah, I really actually don't remember this. Why? What is wrong? This is why this is not gelling. I actually just completely forgot how to do this. That's bad. No, this is pretty much that. Here. Get this value. And then give me a knob to control this value. Frigging show me it in the just. I need you over here. I don't remember how to FL. This guy. Wait, I'm being really dumb. Here. X. Yeah, this is what we're trying to do. Except instead of being the hertz value, we are taking the XY position for that value, and we are essentially like immediately putting it to the on and off instead of the hertz. Yep. All right, you. I need your on and off switch but we don't get that, so we can do that manually. I'm gonna first commit and do this first so we can actually have something to reference and think about. Type that, and then I would like you to just like set yourself to that type. So copy this, paste, paste. This needs to happen in the left and right position for this value. Can we do that? I think we can do that. Let's use the input. Maybe. Ooh, ah, ooh, ah, ooh, ah, ooh, ah, ooh, ah. Should type the coordinates, actually. Because that's how this works. You type S. Yeah. Very annoying. This is the control that we want to build. And then this just goes to frequency. Well, not that, actually. Whatever our input is going to be is just going to straight one-to-one to that. Which would be an knob, which we add with the surface. Let's get a surface. I'm going to actually just do it. You are a knob. Just a knob. Just any old knob. A knob. Knob 6. Knob 6 going there. Yeah. Here we go. This. Frequency. This is what we want to build. Oh, look. Cramping. Because oversampling's off. Okay. Yep. This is what we're trying to do. On and off. Whenever we reach a specific hertz value number. So we need to have logic that does this off onto a specific value always. So what we need to do is I'm going to go to Desmos, and we're going to make that. We will have a value that is always off position, and a value that is always on position. And on position in the left and right position for X needs to be defined by our frequency. So essentially, X is smaller than 0 should equal 0. But also if X is smaller than whatever our hertz value is, then it should be 0. Or, well, desired hertz value. And then if X is bigger than desired hertz value, then equals. Now see, the thing is, whenever X is bigger than our desired hertz value, we only need to do this calculation. We don't need to do this calculation. We don't need to know that X is smaller than that value. But we could. Yeah. We actually this guy, right? Maybe. Maybe. X is smaller. X is bigger than this value. X is bigger than this value. Evaluated to 1. That is correct. Now, next, when this is 1, we want to set it to -1. How do we do that in math? We do that like this. We say that we receive. This is our receive value. I'm gonna do it like this is actual programmatic is equal to this value, which I guess programmer brain, not programming. This is why I do basic scripts. Not, and even this is basic script, so I'm just bad. X is the desired value. Value is 1. Which actually should be on another line, right? Because this is the evaluation, actually. So this is our condition. This is the actual doing of the stuff. So we have our condition, we're doing the stuff. This is also going to be a condition. No, it's not actually. Well, our value is 1, so we actually want to say if our value is 1, is our value 1? Is our value equal to 1? If it is, then set our output to 0. Is that right? Is that what we need? Yeah, because if this is a value, it's true. We want 0. Logic. Logic hurt my brain. Logic not friendly. If value is bigger than 1, but actually if value is equal to 1, then 0. Or the inverse of equal, though. Maybe. Yeah. Is this what we desire? Equal to Boolean. Yeah. Is it equal to our Boolean? Is our value 1? Well, that's just going to give us 1 anyway. We already have 1. How is this helpful? Oh, well, this is actually helpful if we have big number. Yeah. If we're evaluating like 2 big numbers, then it'll give us a 1 value. So if we're at maximum, give us value 1, which we could do. We could say that if this is the max value and we do equal to that, then it is the thing. No, you should probably not pay more attention. I'm doing very silly math issues and confusing myself. Yeah, okay. Let's do this. Multiply by 0? Well, if 0 is multiplied by 0, it's 0, right? Simple math things. 0. You have nothing. You multiply with nothing, you get nothing. That's true. Nothing, you multiply with, you have 1 something, you multiply with nothing, you get nothing. Yeah. Good. Good math. Good math things. Yeah. Yeah. Okay. We have 1, we multiply with negative. You get negative 1. Because we have a 1 and we have a negative 1. We multiply them together, we get negative. Okay. You should just sign situation, which is actually, if we have a positive number and we multiply it with a negative number, it will be a negative number. If we have a positive number, we multiply with a positive number, we have a positive number. If we have a negative number, we multiply with a negative number, we get a positive number. Type stuff. Now I want the inverse though. I want, if I have a positive number, multiply with, okay, I actually just answered my own question. If I multiply 1 with negative 1, then we get negative 1. However, if this is 0, oh, Well, yeah, but I don't actually want you to be these values, though. And doing that feels stupid. Because we have value A. I'm going to just out. One. Bing bong. Bing bong. You need a step. Step one. Step step. Steep stop. One plus one. Okay. This is 0. This is 1. Can we do this in one step? No? Here. Here, make a graph. Multiply with X. What? Why? Oh, I get it. Hold on. This was a float, and it would just do. Yeah, okay. Reason I wanted to do this was that if we do sine of x over here, which is our signal, and we do another evaluation with a, you can see this is the amplitude. So if we do just a multiplied by sine of x, a sine of x, can we do that? This is what we want to do. Purple is our, is it? Wait. Yeah, purple is our filter. And this is going to be stepped. So it's going to be pink, punk, just up, on. Because this evaluation is our other knob, which we're saying is b bigger than freaking 10 or 11. B bigger than 11. Does this work? Is this syntax legal, Desmos? You need something on both sides? Yeah, of course you do. I get that, but is this fine? No. My question mark? I don't know how to evaluate like this. Ternary operation. Ternary operation. This is JavaScript. I don't know JavaScript. Desmos. Copilot? Show me. Show me your ternary. This is the evaluation. This is the thing that is going to spit out hello. Nope. But actually, this is fine. Oh, it highlights it in such a way. That's pretty. Okay. Here we go. Condition. Multiply by value. If true. Plus. Not condition. I don't want a not condition. I just want a true condition. Well, value if false. Yeah. Condition, this is going to be our value if true is 1. Oh, right, because if this is true, this is 1. 1 multiplied by 1, it would be the result of this value. So, yeah, and then add with our not condition. This is our not condition, so this is the opposite of this guy. If it's not that, multiply by 0. But I don't really want to do the syntax. I want to do it the short way. This way. This is it. our piecewise function, but I actually didn't think that it would be a piecewise function because piecewise functions always return that. Okay, fine, fine. We can do piecewise. We can do piecewise. I'm falling in a pit of despair. Okay, we do curly brace. We do our condition. We do our evaluation of true with our colon. And then comma, and then we do our false. Okay, I got you. I got you. I think I got you. So it's going to be like this. This is how it's going to be. This is how it's going to turn out to be. And then we need to still make this in the batch. Okay. This is if true. If true, our value is 1. If false, I forgot the characters, comma. If false, our value is 0. B. If B is our frequency. B is our frequency between 10 and 20,000. Now, this is going to be interesting. Are you turning to 1? You are turning to 1, but why are you not multiplying anywhere? Because I didn't add you anywhere. This needs to be our value of 1. Here, I think. M. B. But not absolute. What? Oh. What? Oh, it's multiplying with B, not the result of B. That, no. No, no. No, no, no. C is equal to that. Evaluation of what this parameter is. C will be multiplied over here. Yes! 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 Evaluation of logic. This is really stupid. Okay. Okay. Okay, okay. Okay, okay. How does this help us to actually do our thing, though? We need, okay. We need to build this section. This C section, this is what we need to make this. We need C. Either on, or either multiplied by 1 off. And this is actually the section that we need, because we already have the first C section. This is C. This section right here, this is all the logic for C. This B, this is B up here. Our knob, that's B. This whole section over here, that is this section of like B is bigger than 11. 11 will always be 1 or 0. That's this section, right? We're saying bigger than 11, which should change for some reason. Bigger than 11? Give me 1. Yes, sir. Yes, sir, it will do that. However, now we need to multiply by -1 plus 1. I'm going to do that. This is really stupid. Why do we need to do this? You probably don't need to actually do this. I'm dumb. Okay, so here we go. Here we go. Value, or value bigger than 1. Multiply. We multiply. We multiply. We multiply. We multiply. We multiply. Multiply. We multiply. Here we go. Multiply. Value 1. However, this needs to be our evaluation number, so we get a bang. Bang in there. Do the processing. Ba ba ba. I wonder if you can get bangs actually from knobs. Bang. Let's go look. I want to just like side load real quick so I don't burn myself out on this. Trigger to bang. Ooh, maybe. Let's see. I'm gonna do this. Bang. But actually, I need the funny icon one over here. I don't know how to get this guy. Control Shift B. Control Shift B. Go in there. Turn the knob. Hey, look at that. It only worked one time. Hey there, brother. Is there anything else? Hello? One bang. Gate a bang with a bang. Okay. B, a bang message. That's a bang right there. Bang. Anything else? Anything else? Anything else? Float to bang. Make a bang. Float to bang. Float bang. Output a bang message. Bang. How about now? Control Shift B. Bang every time. Oh yeah. Very good. Now, the reason this is actually beneficial to us somewhat is that we can actually put this in here, maybe, and then have this always trigger whenever the knob changes. So it doesn't matter which value we get from one or the other. Maybe. Helpful, maybe not in this case though, because we already know we can use the first value always. Okay, so ding, bong, ding, bong. This needs to multiply with negative. We have a NBX, number box. -1, please. Oh, I held Alt instead of Control. Yes, going. Multiply -1. We should get a value. Wonderful values. This has all been wonderful. What? Why are you not calculating? Calculate for me. Are you value -0? Are you actually very small float number? I would like to not have float number. You silly. You silly. -0, still 0. So I'm gonna accept you. You're not so bad. Okay, here we go. So we have a value of -1. We need a value of actually the other direction. So that it's just flipped. I mean, we could also do absolute, but that's dumb. We're just gonna do addition. I'm gonna use this value because I'm not feeling like it to do it the other way. Maybe this works. Why'd I resize this? Go back to your size. You are my second value. You are my initial value. You go over here. Tell me what value you are. I actually should have removed this guy, but that's fine. We can still evaluate him. Tell me your value. You're 0 at all times. Yeah, we're just gonna have a constant, aren't we? That's perfectly reasonable. Why are you changing? Stop changing. Here. Have my son. A value 1. Eh? 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 Look, it works. Look, it's so efficient. You don't want to look at my script at all, and you're just going to be so happy that it works. Smile. I'm gonna show this to my friends, and they're gonna be like, "What the frick are you doing?" Or like, "Bro, don't at me. Don't at me for math. This is really bad." Now on the positive note, we can remove all of these little guys that are in between here, and it should look nice now. You go here, you go here, you go there, and it should still work. I totally didn't break anything. Smile. Okay. Great! Evaluation! totally turns off perfectly. And there's totally, I'm just gonna totally ignore that it has phase change down here. It's good. We're good. uh, okay. You can also go away. You need to live here. You need to live here. All the guys that go into one of these operators, they need to live. They need to continue existing just the pretty beautiful way that they are. Nice. Okay, that's good. This is good. We have our first part. Does it need to have all this logic? No. My friend is definitely going to teach me very good ways of doing this instead. Yes. Okay. Why do we have so many things on the screen? I've been owned into like this little piece of the screen only and have not been focusing on anything else other than this and math in my head. Oh gosh. Can't wait to get to the recap after this multiple hour stream. We're like, oh yeah, this is the thing that we made in 3 hours. People are gonna be like, how? Okay. Okay, but this isn't good now. This is very good. We will get much better at doing this very soon. And then we will not need to do these silly funnies. Hopefully. I'm also probably gonna just dip into like some patches. Because if we see any of these patterns, then we just know, okay, yeah, so this maybe is the way to do it. Maybe it's not. It probably isn't. But that's cool. I like this. I like this a lot. Also, there's some way to align these. If I remember correctly, some shortcut you press with an arrow key and it does the alignment. I know you can right click it to do alignment. Align left, like that. And this will make stuff just look nice. So we can do this knob, align left, think, and then I think you can snap it to the grid somehow. And then shift does incremental. Okay. Okay. Never gonna live this down. We're getting there. This is how you start. No shame. No shame. No shame. Get out of here, Slider. Get out of here, Range. Don't need you. Don't need you here. You make me sad. Okay. Output down here. We are going to do part 2, which is going to be the simplest thing you have ever seen in your entire life. We're literally just going to copy and paste. You. Now, this needs to change. Also, this is going to be a problem. This is going to be a big problem. Will it remember our values as we load them? I feel like it's not. I'm gonna try it. We know what these values are. It's totally fine if I forget, you know. But like, it's a big problem if you reload the patch and it just goes, whoop. Those number boxes you were using, they won't have any data inside of them. So let's just do that. Plugdata effects. You. And they're empty. They're empty. Okay. This is fine. This is fine. What we need to do now is that init message thing that I was talking about earlier. Initialization message. And then this needs to send 2 things and then send into here to actually give us the numbers. I feel like this is not supposed to be a number box. Here, let's click here. What are you? What do you use? Is that a number box? No, because it doesn't have the little angle on the side, right? So no. What are you using for this? Tell me. Tell me what you are. Number atom box. What are you? What's your name? What's your actual little Change your values. What about in here? Little angle symbol? No. No. Float? Maybe we want float values. Maybe we want float values. And I totally didn't do this wrong, Smile. Okay. We have our evaluation of 11. We have our evaluation of 1. And then we have our evaluation of negative. Actually, other way around, sorry. Yeah, this is 11. Over there. 1. But it's multiplication, we're doing negative 1. This guy. You are 1. Surprise, surprise, it should still work. It does not work. Why? It's not. Do I need to do that and then change you? No. Oh, wait, the DSP is not running. 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 Come back. Yes. Yes. Incoming signal audio routed to, yeah, right channel. Good. How do I enable this DSP from the start? That's going to be part 3. Okay. So this works now. Very good. Very, very, very good. Ha ha ha. I am not losing my mind. Okay, so good. Let's write this down. This is important to know. Okay, so for numbers, for numbers, or well, for yeah, let's just do numbers. Use. I don't like this feature of my Paint, by the way, where it just deletes like chunks of data. It's very weird. Okay, for numbers, use float. Good lesson we have learned. However, we still do need to evaluate if that actually works. My bad. Close this. Plugdata. Come here. You still have your numbers? Oh, no. No, my children. Wait, do we need to set your default values? Is that what's going on here? No. Is this going to be a moment of I need to probably get the other version of Plugdata? Because maybe this is also broken for me for some reason. I don't know. Help. Help. Okay, let's do this. Plugdata. Or, well, peer data. Save float values. Store a floating value number. Yes. Yes. Let's do this. Here. Peer data, example. I should have done this from the start. Example, GitHub. Oh, it's going to be so wonderful. Look, we're going to just go in here. We're going to go to example, and it's going to be like, hi. Hi. I'm here to help you. This is hello world. We don't want hello world. We want something more. Nope. Here. Let's just open it. Here. What are you doing? Tell me. It is literally just printing hello world when banged. Okay, that's good. Good. Thank you. That was so helpful. It was amazing. Okay. Let's see in here. Hello? Any information here? Playing an audio file in PD? Yeah? Yeah? Now Does this have a float? Let's see. Here, tell me. Do you have a float value? Float value I can borrow. This is a number. What is X? Hello, X. Hmm. 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 Yeah. Yeah. Yeah, look at this. Hold on. What? You. I remember you. And what is supposed to happen is that if we have a pure data patch and we save it, it is supposed to save that value into the patch. And then when it gets loaded, it's supposed to remember what that float value is. However, here's a float. This is this F, right? We go here, we do this. Oh, we do this, type F. The stored value? The stored value. Okay, so they have a stored value here. And it is incrementally changing? What? Is that what's happening here? Bang, and bang has, boom, goes over here. Stored value over here. No, because it's what goes in the side. This is the stored value. Store the value, no output. Output stored value. It's a float. Well, if it's a bang, output the stored value. So that's going to be here. Just go out. So bang comes in, it goes, sends the stored value. Stored value is what? 0. It's nothing. Nil. It goes out. It's added to 0. And it's stored again. Okay. I am confused, to say the least. I sort of maybe. I'll be honest, chat. I don't know. Let's see here. How do we store float values? Let's do this. We have patches. Can we learn anything from them? Which one of these is not gonna be painful to open? Yeah, you. Look at you. Are you friendly? Yeah, look at that. What are you? What are you? How you save your value, huh? Give me instruction. Give me stuff. A clickable message box. Interesting. Message boxes hold one or more messages that get sent to its outlet or given destinations when the box is activated. This box gets activated when load bang. On load bang, it gets sent. So plugin latency. Good. This is block size, by the way. Okay. Very cool. Message boxes. Okay. Message box in PD consists of a selector, a symbol. Symbol. Hi. A simple message. A simple message. A symbol message. Okay. The selectors float, bang, symbol, and list are common, and special selections in PD. Numbers and lists that start with numbers are automatically given the float and list selectors. Is this like typing system for like programming? Because in Python you do like the thing where it's like it's like this. I have my value of X. I'm gonna set it to a float. Or something like that. And then you set it to 1.0. or something, right? This is known as type hinting for uh, Python. Also for GDScript, it's like similar. You have like you have the colon, you tell it what it is, it evaluates faster, essentially. In other programming languages, it's like literally first say it's a float, then give it the name, be like Bobby's number. Bobby's number. And then it's equal to whatever you assign it to. Bobby's number of 5. Because Bobby's cool. Because he has the number 5. Yeah. Yeah, like Pascal, yeah. Exactly. Yeah. Okay, cool. So this is good. This is good to know. This tells us, okay, we can freaking, you can have float, you can have bank, you can have symbol, you can have list. Just throw it in a message box. Message box, it will figure it out. It's cool. So here's the thing though. How? Okay. 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 Yeah. Number box only evaluate or kind of save the number for a little bit, I guess. Number box just tells us number. Uh, so a message is what we actually desire. So actually a float number is really cool also because we can just like move the thing and it sends the thing. But actually what we want is this. Because every time we send this number, it will send it. And remember. Okay, very cool. This is also a message number. It's just sending a big old thing, stack of stuff. Yeah, so this means that every time we put a comma, it will separate. This is good for presets. So if you have like a bunch of stuff, you can send it out and then you evaluate it in a way and split them up somehow. I'm so sure you can do this. What's this? Print nothing. Yeah, okay, yeah, sure. But you're actually printing something, so you lied to. What values you're printing? My receiver name over here. Okay, my receiver name 858, another receiver, -45. Okay, so over here. That's cool. Yeah, so this is how you do that. This is the input for like a thing. You receive, it goes over there, sends into the box, that goes out. You're done. Next number. This number goes in here, goes out there, goes up there. This is literally like the way that we probably should do this. So good stuff. Thank you, Ewan Bristow, for having this here so I can click on it. Don't save any changes. Okay, we're good. We have learned a little bit. Let's go. You. We're not going to do the send and receives. I think that's a bit overkill for what we need to do here. Oh gosh, actually would have loved if you could like just put them all into the thing. That is totally okay though. So message, can we store, is it this? It's not this. Don't do that. Don't do what I do. We're figuring it out. Figuring out. Failing miserably. But we're figuring it out. Okay, so how do you do this? Control 2 to do a message. Control 2? Control 1. What are you? You're just here's a symbol. Symbol? Object. You're an object. Okay, good. Good to know. You're a float. You're a symbol. This is a symbol. Why symbol? Why do we need symbol? Bigger screen, please. Drum roll. These GUI objects, we already read this, but I'm going to read it again because I don't understand. These GUI objects display and send atoms. Right. Atoms or lists. Okay. An atom is a single element message, a symbol, or a float. Okay, I got you. A list is composed of more than one atom. Yes, okay. I get that. I understand what a list is. Why the frick is it called an atom? Okay. One atom and can hold floats and or. And or? Wait, so anything? Anything in this 2D array? Yeah? Okay. These objects may be created by selecting number, etc. from the put menu? The put menu. Excuse me? The put menu. Chat? What? What? Huh? The contents can be changed while the patch is in run mode. Okay, that's good to know. That's this mode. As opposed to edit mode. Yeah, okay. Okay. What? I'm still at put, people. What? Huh? The put menu? The put menu? Come here, symbol. Get out of here. The put menu? Receive symbol. Send symbol. Yeah, okay. Yeah. Huh? Where in the living daylight? Where in the daylight is the freaking put menu? Who? Okay, here we go. Plugdata, put menu. What the frick? No, not in this documentation, it ain't. The put menu. And why is it in quotes? Is this an actual menu I can see? Is this theoretical from the list? Is this jargon? Is this funny jargon? Let's read on. And then we circle back. And we're like, from the put menu. Okay. Clicking on an object activates it, indicated by a thicker border. Yes, this is true. More like a colored border, but sure. Clicking outside the box deactivates it. That's so true. Look at me doing this. Yep. The box deactivates. Yeah, okay. When active, you can hit enter to output the current value. Okay. Good to know. So it only bangs when you press enter. Good. This can be done multiple times. That's good to know. So it's a text box. Very good. Okay, thank you very much. You can also type new values using backspace to correct typing is allowed. It is a text box, people. And hit enter to validate and output them. It is a text box, people. You can cancel the typing action by re-clicking on the object to keep it activated, or outside it to deactivate it. Cancel the typing. Yeah. I click away. It's still I didn't mean to type that. It's still that value though, but it did deactivate the typing. You are so correct. Okay, we get it. Blobby. You can also type new values. Yup. Backspace to correct them. This is just a text box, in my mind. You can cancel it by clicking outside. Yup. Outside it to deactivate it. Okay. Double clicking activates a text editor. Yup. You can navigate with arrows. Yup. Backspace. Yup. Yep. It's yup. Copy, paste. Yup. We can probably make this really big. We cannot resize it. Not in here, at least. Here. Give me a symbol. We resize big? Oh. Oh, so we can't make you long. Only 36. And that's where they made a mistake. Not really. Okay. So double clicking activates the text editor so you can navigate with your arrows. Yep. You're over this. Good. You can change the value upwards or downwards by clicking and dragging up and down. Okay, that's very nice. Thank you. Except it only banged the value. When I'm over here, does it let me do it? No. You can also change a numeric value up or down by clicking and drag. Shift click changes the value in hundredths instead of units. This works for both number boxes and individual numbers on a list. This one will let you do it. Number Adam. Oh. Oh, these are all Adam boxes. I get it. My apologies. I am very silly. I understand. This is an Adam box. This is an Adam box. This is an Adam box. How do lists, quick question. How do list? Wombat, weasel, wallaby. Wombat, weasel, wallaby. Very nice. Set 4 dog 5 6 donkey. Okay. Very good. Thank you. Very weird. Why is this here? 1 2 3 4 5. That doesn't seem right. Messages beginning with a number are implicitly understood as lists. Beginning with a number. Okay. Lists starting with a symbol must be preceded by the list selector to disambiguate them. Basically, if it's a list, you tell them it's a list. If it's a number, you don't need to tell them. They know. Set message changes contents but does not output them? Oh, it doesn't print it. Nice. This is preload. That's very good to know. This is very good to know because this is how this stuff works when you do like, well, not inherently, but like it sort of works this way where you like click and it highlights it and then you click double click and it actually goes. Not actually. Okay. Set the changes content, but don't up them. Yep, that's good. Okay. This is a preset selector, and then you press the load button type thing. This is probably the load. No. How do you load it then? Can you do that? Numbers up and down individually and or change a click. Really? Oh, but it outputs it though. Wait, that's cool. That's very handy. This is like loading a preset before it's actually loaded into different stuff, and you just change the number on the fly, and then you print it to the thing. But it immediately prints it though, which I don't quite understand why you would do it this way. We'll get probably like lots of examples later that do that kind of stuff. It's quite fascinating. This is very fascinating. And you load this guy. Can you can you do this? Hold on. Let me edit this. Set this list. Can you do that? Or does it add list to the thing? It adds list to the thing. Wait, how do you do that then? I guess set automatically is a list, but me. Okay. I'm not gonna think too hard about it. We'll come back. It will make sense the more we play with this. This feels so much equivalent to like me opening FL for the first time and be like, hey dude, what is Maximus? What is this thing? This very obscure thing called multiband? Why does it still do this? Yeah, like frigging opening Maximus, being like, okay, I'm gonna actually take the time and read the manual. Go like, okay. 3 independent user definable high, mid, low, HML frequency bands. You know how long I sat with this first sentence and just went, okay, I'm gonna break this down. 3 independent user high, just this, user definable. And I broke this down word for word and I was like, okay, I'm very dumb. I don't understand. User definable, what? Yeah. It feels like that right now. Like they're saying words, but I don't understand you. Okay, more details, PD properties. You can right-click the object and ask for the properties window to change its parameters. Really? Right-click for properties? Really? But how? Oh, wait, come back. This? Not this. This? Properties. It is this. Wait, can you do it out here? You cannot do it out here. Liars. So you need to be in this mode. This mode, properties. But then it just brings up this window, which we already have open. Does it open this window for you? Maybe this properties. No, it just opens this. What is this? Click the pin. Inspector auto. Oh! Wait a minute. Oh. Wait, but can't it always just show one thing, even if you're clicking off of it? I guess not, right? To hide. Yep. But if this is here, click to auto show. But it's not auto showing. It's just making a little dot. Show me the inspector. I pinned you, apparently. Please? Oh, gosh. Okay. Just stay there. It's fine. We'll continue learning about the innards before we figure out the workflow. Okay. Control click. Right click for properties. Yes, this is true. This is so true. Properties. Okay. We got you. I funneled into the thing. PD width. Subpatches below offer details on each parameter from the properties window. Yep. Width of 0. Only one number. That is a number. This is also a number. Okay. Number atom box object toggles between 0 and a non-zero value. If you click on a number box while pressing Control, on Linux or Windows, or Command, of course, Mac. The non-zero value is the last non-zero value that the box holds. By default, this value is 1. What? 0 and a non-zero value. Oh, it toggles between a value of 0 and 1. That's the whole thing they just said here. It will toggle between 0 and a non-zero value. If that value is something like this, though. What was the shortcut? Control? Yeah, okay, I get what they're doing here. If this value is big, I control click it. It'll be that. If I control click it again, oh no, it is not what I actually thought it was. Is it? Yeah. Okay, no. Always 0. That's not a toggle. It doesn't toggle. Hello? It sets to 0. Does not toggle. 0 of 10. Would not recommend. Lobby. Lobby doesn't set to 0. Run control click. All GUIs. Oh, this is a helpful window to have had open. I would have loved to see this at the beginning. Hello, radio. I've seen you. View meter. View meter would have been so helpful. Good. Very good. Very good. View meter is very helpful. Okay. Canvas? What is Canvas? Tell me of yourself, Canvas. Reference. No, not reference. Help me. Help. Yep. GUI, GUI, Canvas. Graphical UI, graphical user interface. The Canvas object is a simple graphical user interface used as a background and or to display a symbol. Oh, more symbol. It can also send its position when queried. Inserted from the put menu. I still... Oh! Chat! This is the put menu, I think. Is this the put menu? Is this what they're talking about? Is this it? Inserted from the put menu, named as Canvas. You? Do you named as Canvas? Here it is. Is this the put menu that we have been searching for? Inserted from the put menu, named as Canvas. Or its shortcut. I so think it is from this. Why? 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 Why in the documentation? Is this what it's called in Pure Data? What? Pure Data. Put menu. Images of patches. Oh my gosh. Oh my gosh. It is literally a drop-down menu at the top left. Not in here, it ain't. Oh my gosh. That needs to change, people. People who handle the documentation, please run a script that just search and replaces the put menu with maybe the object browser, I would hope. Unless I am insane. Is there a put menu in here? I don't think there is. So therefore this language does not make any sense. This? No. It's a palette. No pieces of palette. Let's make a new. Okay. What? I'm flabbergasted by this whole like put menu shenanigan. Okay. Anyway, now we know. I'm gonna make a note about that too. Not that I need to remember it, but just for the freaking sake of what? Put menu, by the way, actually equals what is it called now? I'm blanking just because I'm done. Show object browser. No, actually, what are you called? Add object. Okay, thank you so much. Add object. Thanks. That looks like the exact same letter. My handwriting is bad. If I don't sit correctly, I'm bad. Okay. What? All right. What? Who? Who? What? Okay. Okay. No, this is fine. This is great. I'm gonna make a new layer. Okay. I need some water. Oh. Matt, you staying hydrated? That's insane. I'm tweeting about this. What the frick? What? Where is the one with the quote? Yeah, this one. We're just gonna take this and I'm gonna paste this in here. It's just gonna live with all of this. Paste. Where would it paste it? Of course it would paste it probably somewhere far, far, far away. This one? Painting layer. Can I paste in here? That is duplicate. New. Can we paste in here? I don't remember. Definitely not normal shortcut. Okay, whatever. But wow. Okay. This one? No. Okay. It's fine. It's not. I actually do want to make this post because I think it'd be funny. But I can't because I don't know. Program. Okay. Who? You? You look like a button I should press. What's this? Yeah. Yeah. What is that? Oh, and now it's over there. Wow. Oh, now it's floating. Get in there. Okay. We'll get back. Okay. Now, I do actually need to grasp still what the frick a symbol is, other than text, which would probably be a string. Let's plug your data. Is a symbol a string? No, not out there to ask. In essence, it is a string. Good to know. That is any type of character system. Like it's A, B, C, D, anything like that. Good. Good, good, good. Okay. So symbol, essentially a string. However, we have number atom boxes though. And this let's look at what a pure data atom is. Does it say pure data atom anywhere? Atom box shows list box properties. This is an issue. Nope. Pure data. What is an atom? List of objects. Mm-hmm. Atom. Not included in this list. Touch in, touch out. MIDI in, MIDI out. Sysix. Yeah, I know about Sysix. Poly touch in, poly touch out. Okay. Sound filer. This read and writes tables to sound files. Okay. We're just getting a lay of the land. We're just like figuring things out. I just want to like read through some of this just so we have like some semblance of like, oh, okay, this is generally where things would be found if we would need them. Which is a little bit insane to do. Oh, look, bonk. You find funny things, see? Attack detection and spectral envelope measurement. This is handy. This is handy because one of the other things that we might make at some point is a frequency shifter where it resets the oscillator every time. This is very handy to know because this gives us the attack detection and spectral envelope measurement. Yep. Hilbert transform. I actually do want to just pop in here and see like, yeah, it's just in out. Yeah, good. Real part, imaginary part. It's just going to be the phase rotation. I imagine it's going to be, I actually just want to take a little peek under the hood, see it in action, you know. Totally not stalling. Switch. Okay. Here. We will make a new one. I'm gonna just this is also good, by the way. The reason I'm also doing this is just so I can get used to like thinking about needing to put an ADC and not like some kind of other input. Need it out. This goes there, this goes there. We should get a diagram. It's not doing that because we need to enable you, and then we up the volume. Now you work. Good. Good. Okay, so Hilbert transform. Hilbert transform, please tell me what your phase is. I wish I could like drag you here and like, oh, chat, it's the same as it's the same. It's the same as freaking DaVinci Resolve. You can do that. Oh, they are using the all pass filter version. It's gonna say it here, isn't it? Hilbert transform. The name is abused here according to computer music tradition. Puts out a phase quadrature version. Yeah, quadrature, phase quadrature. It's this. Boom, boom. Of the input signal suitable for signal sideband modulation via complex modulation. Yep. This is what we're getting. It is rotating the phase from the original position. There's another sine wave in here. like if we have, I'm just reset all this. Okay, so we have sine of x, uh, sine of x, multiplied by pi, and the only reason we're doing pi is so that it just like goes from 0 to 2. If we do 2 pi, we get the actual like full rotation in one value, which is how serum works. So 0 to 1, single sign. Okay, so how this works is that you have this guy, which is our original version. I'm going to make this like f of g is equal to that. Or, well, that's not going to work because we need x. Yep. So f of x is that. G of x. G of x is equal to... Actually, I don't know how to do the phase afterwards. Do you? No, because that's translation. It's over here. So you negative or positive value your pi with another pi, and then you get like rotation, and then you can multiply that, and it goes wink wonk wink wonk wink wonk. It's great. So if this value is 0, no phase rotation change. It just is pi times 0. It's nothing. If it's 2, it rotates twice, or well, single value, because 2 pi is full circle, circular. Now, what happens with the quadrature rotation thing is that we have a quarter of this, which, I mean, 2 times 0.25 is 0.5. Yeah, there we go. So this rotates 45, like in a 45-degree range. We can get that value by doing like this value divided by 180, maybe, no. Don't listen to me. Okay, so anyway, we have that. This is our first rotation. Then we also have just our normal sine of x times 2. Come here. Let me get you. I don't want the whole thing. It's fine. Come here. Come here and live over there. I just want to plot you so you just always live here so we can see the rotation actually happening. So first, that guy goes left. The other guy goes right. This is actually maybe wrong. I think it needs to be 0.25. Because it needs to be... they both like rotate in a specific rotation. That's 0.25. Yeah, it is 0.5. My bad. Wink. I don't believe myself. It is okay. I have this saved, but I'm gonna do this by hand anyway, because then we can just evaluate it afterwards. So this is gonna be g of x, and then we're gonna do negative this value. Eh? Wait. Excuse me, but what? Right. Negative that value. There we go. Yeah, so this is too much. See, these do not rotate that much. They need to rotate by a value of 0.25. 0.25. There we go. That is that. This is going to look the same now as this diagram, except you can see that there's like the imaginary like black line in the middle, which is our input. So what essentially happens with the Hilbert transform is take your input, shift one early, one late, but you can't actually do that. Oh, I'm gonna have to leave, restart my consciousness, aka sleep. Okay, yeah, cool. Take it easy, Avon. Thank you. Thank you for like hanging out. I hope I'm pronouncing your name right. Heck yeah. Thank you for joining the journey. It's been cool. We are learning. We are learning progressively. But sleep well. Take it easy. I salute you. 070707. All right. So yeah. So we have this. Our input is the black value over here. Just plop that on top. Then as this changes, the phase rotation goes early and late, but in digital, we can't go earlier. We can't make something earlier. So we delay everything else, or we make everything late. Which essentially is like plus A. I think it's going to be this translation, maybe. No, sorry, that's up and down. It's essentially going to be like this plus that value to go to the right. That's like all. That's all I'm trying to say. These values, all three, all of them, are going to just move to the right by that amount. So it's like pi a, even the input. Sorry, negative to the right. Negative go to the right. Yeah. But this is gonna be again. So negative pi. I think. That work? That work? So yeah, red goes to the right. This also then does another round of negative pi a. And then they all just move to the right. So you can just move them to the right like that. So original signal just stays where it is. And then the copy of the signal like rotates 90 degrees out. Is what you can do maybe. But like yeah. In real calculation. That's why we do well, sort of not really. It's like the way that they do this is that you have all pass filters. And your one set of all pass filters are on the left channel, and the other set of all pass filters are on the right channel. Excuse me. And they then are changed in frequency. So if we go over here and we put our Hilbert transform, is this the imaginary part? It is. Okay, so if we disconnect this guy, bloop, away, put this on our left channel, and then well, this guy needs to also go to the left. So take the left signal. It doesn't really matter because this is a mono signal that comes in, but you can see all pass filters, and then we're just changing the frequency so that we have a distance. If I measure here, we have a degree of 0. We go up, we have 90-degree shift. And this 90-degree shift is in the center, is actually where our original value should be evaluated if we ever want to dry wet this type of thing. Yeah. This is going to be so cool. This is going to be freaking awesome because we use our Hilbert transform to build really cool stuff. You can modify like super wide side signals that just cancel each other out. You can like rotate the left and the right by 90 degrees and then merge them back together. And I think this only clears the state. Ooh, wait, that's a problem. I might need to build my own Hilbert transform then in that case, because we need to change this progressively over time. E, ooh, ah, ooh, e, ooh, ah, ooh. Okay, that's fine. I did want to gander in this direction though. Oh, no, FL. Oh, FL says it crashed, but it didn't. I am dead, but I'm alive. That's FL. FL's dead, but it's alive. Oh, it's ticking. Tick, 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 tick. Okay. So, okay. Let's fix this. We need message boxes now, actually. But I think what we need to do is probably have a message box, just each. But I'm not sure. I'm really not sure how this is supposed to be calculated. Let's just try it. I'm gonna give it a shot with just normal message boxes, and then give it a shot with other values. So value 11. Can I clear this? Can I clear you? Clear. Clear our console. Don't need any of that stuff. Okay, so this. Ooh. We don't always want to have this though. Because I was thinking like we could put this here and then put this and that, and then we'll bang that. And that will make it actually send its value out there. Which works, but it's not what we really want to do. We really want to do is probably have just like a bunch of these guys for now. And then this is -1. Evaluate that. And then this is just a value of 1. Evaluate that. And should get our diagram back. Hello? Go. I was going to be trolled by the volume slider. All right. Yeah, so this works. Oh, wait. Ooh, wait. Why? Are you working? Yeah, you are working. Okay, very good. Very nice. Now, ideally, we actually do want to interpolate this. Because that would make this like fade in a nice way. But this should be good for a rudimentary like tool setup for now. So can I give this a name? Variable, send symbol, parameter. Oh, can you assign parameters here? No. Parameter. Interact with DAW automation, yes. This inform DAW about change state. There is reading, one is writing. Received DAW parameter value. Float. Set DAW parameter value. Received DAW parameter. This is where that thing happens. This goes here, and this goes here. But I'm not going to do that yet. Just wanted to show that. But this somehow gets assigned to a parameter value, and I think that is over here. Oh, I didn't want to go on you. Great. Param1. Do we just, is this the string of the parameter? Or is this param21? What? These are param name GUIs and param name GUI are pair. To send and receive values directly to GUI objects? You can do that? You. Really? Yeah. Oh, interesting. Oh, interesting. How fascinating. Okay, that makes sense. Thank you. So, standard way of using this then is param with param name. So it's going to be the name of the thing. This though, y value. Why value 1? Why suddenly value 1? I would like to know. Oh, this is some interesting stuff happening here. Okay. We will come back. We will come back to this because we do need to do this for automation to work. Don't save. Okay. First of all, we need to finish doing what we were doing, and that is a init message. Now, I think it is a load bang. Bang on load. That is true. That's so real. I need you all to just initialize. Oh, this is ugly. Ooh. 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 Oh. Now, there is a way to make these not curved. Oh, and it looks so much worse. Nope. 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 No, 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 no. Okay. You here, you here, you here. We will deal with it at another time. Okay, so you can be deleted. I do need. Ooh, I really don't like this setup for doing this kind of stuff, but it is okay. Do that. Now, with us doing this, I should be able to save this. I should be able to close this and delete it, and then load it again, and it should just work now. Excuse me. So ideally, I turn this knob and it works, except not with DSP being off again. Always gonna be trolled by the volume knob. Okay, that works. Very nice. Now we need this entire logic to just come with us again. Come with me over here to the corner of the depths of the sea. Low pass. Oh gosh, oh gosh, oh gosh, oh gosh. Okay. This is our high pass filter. This is our change. This is the original guy that we need. I need another one of these floats. Float to signal. There. Put you on the left this time. We're gonna get very good at this at some point. It's gonna be fast. And we just make a thing. For now, we're doing a slow-mo. Slow-mo, one at a time, understand stuff, and then we will get there. We don't need this knob. Do we? No. No. Be gone. Yeah. Now this value needs to be at the top. And then, ooh, I need to put you into the chain. So, you do that. Ooh, wait. It needs to happen in series. And then we need to bypass you going around. Ooh, I think. Yeah, okay. This guy, you come up here. Come here. Come here. Come here. Come here. Come here. Okay, so you always go through the low pass. Except low pass is going to bypass itself on the outside. So the diagram for this is going to look something like this. We have our input. I'm just going to actually write it. Every input, like that. We go down. We go into our high pass. Actually, we should go into it last as a safety measure. If we do end up automating the low pass over something, because sometimes automation, if it is very steppy, can cause low frequency DC offset. Anyway, first build, we'll do a jank. We fix it. It's fine. So first block over here is going to be our low pass. Actually, it's currently our high pass. My bad. I was thinking about how it should be, not what it is. So we have our high pass filter over here. And then to bypass this, we have a block over here. And what happens is that we have that, and then we have a switch. So our switch opens over there, and it goes in here. And then this switch is connected to this switch over here, which I will close initially because we want it to be active. And we should also not make a node where this is connected. Otherwise, it looks like it's going to disconnect at the same time. Okay, so this switch is connected to this switch. It is good. Our input goes to high pass filter. High pass filter is engaged when the switch is enabled. And then after this high pass filter, another block. And this block looks almost identical. It actually looks identical. We have our low pass filter. I'm going to draw that nicer. There we go. And then this also has a copy. And then either is engaged or not engaged. Like that. And then over here, we have the same thing. Another switch, which is engaged. And the reason we do this engage section over here is that we want to show that when this gets flipped, then this will open and this will close, which means that that signal can then run through. Goes down, goes over here, and goes out, and it goes out. That's the whole circuit. Circuit, I say, but in reality, it's just a diagram. This also links to that guy. I'm gonna do this all like messily. Here we go. Okay, so input, high pass filter. We did this section already. It's so cool. So, second half, I wonder if we can make in-between nodes just to connect nodes together, because I want them to look nice, so it mixes into one section and then goes to the next part. It just mentally makes a lot more sense then. But for now, it's fine. Okay. Next, we do need to load bang this again. I wonder if we can have multiple load bangs. Are we allowed? Can I have multiple load bangs? Send a bang with load to patch. Yep. Load bang outputs, object outputs a bang message when the containing patch is opened and opened as a document or included in another patch as an abstraction. Okay. Good to know. Load bang objects within abstractions send their bang messages before load bang objects in the calling patch. What? Load bang objects within abstractions send their bang messages before load bang objects in the calling patch. Oh, okay. Yeah, that makes sense. Essentially it's saying like the inception box, right? So we have box A, and then inside box A we have box B. And it's essentially just saying box B will be first. And then box A will be second. And then it will run like the entire thing through the signal chain. This is when it gets started. So it's like, first I will load B, and then I will make sure it runs. And then I will load A, and then I will make sure it runs. Yeah. Inside, outside. Load bang objects with abstractions. Send. Yeah. Okay, we did this. You can force a load bang to fire if you send a load bang message to the patch. PD messages. PD messages? Messages you can send to peer data. Hello, peer data. I would like to send you a message. Why is Plugdata have a put instead of a add object? We can use both the send object or message boxes to send messages to peer data. Here are some messages that make sense for you to send to peer data from within a patch. Conversely, you can also send peer data, send PD these messages via PD's command line. What? Okay. Compatibility messages takes a version number and sets the behavior of some objects back to that particular version? What? That's insanely cool. I kind of understand what they're doing here. I think if you have like a old peer data patch and it worked a certain way and they have like certain things that they changed, this is what it kind of means to me. Maybe it is this way, but I think if you set compatibility and send that to PD, then it will revert back to that older version of peer data. But that also doesn't quite make sense to me because does that mean every version of peer data exists when you install Plugdata or peer data? Because this is a legacy type like conversion thing, right? I think that would make sense to me if that is how this works. All right. Yeah. So anyway, we don't know if we can do multiple load banks. I'm gonna do it anyway. I don't care. So we need this to be a value of anything below, just below this value. I do wish I could just nab this value out of the thing. Can we? Can I get this value, please? Not from the outlet, it seems. Oh, look, you can set foreground and background colors from the outside. Yeah, that's kind of unfortunate. I actually would have loved to be able to grab the value, the max value from the output stage. I wonder if do people sometimes use sliders in between? This is a 2D slider, not a. It's not the guy. It's not the guy. Save. I'm gonna go here. Vertical. I will go vertical. Steady on click. Jump on click. Okay, so can you initialize? No. Yes. Yes. Answer. It is no. Okay, so we have this value. This value of 20,000. We need a value of just -1. So I'm just gonna 1999. Can I? So anything just below this, get in there. You bigger, wider. Okay. Load bang there, load bang in there, load bang in there. I think it should be any value that's smaller. And then changing this value. Should change that, but we need to evaluate or check if this actually does work. And we need another multiply to do the switching. Ooh, yeah. We do need this to merge somehow. Um, um, just do that. Just single. No, it is not. It is not. It is just not. Ah, yes. Thank you, 2-channel mixer. Hmm. All right. So hmm. So we're getting better at this at least a little bit. So the first thing that we need is this value that just turns off for you, and that's gonna be this guy. Let's check this value before we do that though. If we do float, which should be here, we can grab this number. Just look at it. Look at this value. Look at it. It's not changing. It's not evaluating as true. But why? You have a value that is, in fact, this value. Yeah. This value. Is this value smaller than that value? I would say so. I would say yes. Me personally would say that value is definitely smaller than that value. You're, you're not meant to need to have them go into the same direction. And this should be calculating the same way as this guy, you know? So why? Why don't you evaluate on? I am so curious. Why? Why do you do this to me sometimes? This value should be bigger than you. It's 20K. This value got loaded and loaded again. Now it works. Oh, you silly, silly, silly program. Okay, that works. Fantastic. Yes. Awesome. And then it turns off. Yeah. Yeah. Now, does it have oversampling? Not really. Can we do that at some point? Yeah. Yeah, we definitely can do that at some point. Okay, so that works now. We do need to bypass it though. So we need another one of these guys. And then we need to pipe in just a straight up duplicate of both of these. Yeah. in there. This is why I didn't want to do it this way. If you have like an intermediary guy, it actually makes a lot more sense visually. And this is kind of just where we're at right now. Ugh. I really don't like how this looks. Anyway, now we have this guy. He's being evaluated, so he goes in there. Wait, are you this guy? Yeah, you are. We just need the signal. Go, child, in there. Oh. Oh. Oh, it does not work. Oh, it did not load my children. There we go. We did it. We did it. It turns off. Very cool. Very cool. This took forever. Look at this tiny patch. It's fine. This is how we learn. Now we know so much more. Although I'll probably need to do this again at some point. So I can just remember everything. Yeah, this is pretty much what we need right now. And then we need to just set these knobs to parameter values so that we can automate them inside of the DAW. So that should be pretty straightforward, maybe. This should be RAM1. Boop. I do think these are the names, but I'm not sure. Can I just give this a name? Maybe like HPF. Am I allowed to do that? Does it know? Can I make editor thumbnail? Make editor thumbnail. It's gonna make a loud, snappy sound. Yeah, it doesn't set it over here. So we actually do need to use those parameter names. Name one. How do we enable it actually? Because it's disabled, right? Because it needs to update it. Be like, hey, I'm actually being used for something for once. Anyway, this value go there, that value go there. If I change this value, you don't do. You don't do it. Don't do it. Not today. If we set that though, should. So this is a latch of some kind. Where are you? Possibly. Toggle. Yes, a toggle. It turns on and off. Other thing, not a toggle. Turn on and off. So that works. If we then move this, if I do that and I move you, you don't update the DOM. I forgot. Yes, you need to click here. You need to click here. You click that. And then you can do HPF. That's our new name for our control. Ooh, it lets you update them? Yes. Very cool. Very cool. Okay. That's so easy. Look, it should work now. Maybe. Oh. Oh no. Oh, we need to actually set this to a value of 1. This is why I did the thing always with like changing this. We need to divide this by its own values in order to get 0 and 1. Okay, so this is not going to be as straightforward as I thought it was going to be. So you always get your values. This is good. This is good. So if we change this, it should at least like, no, Can I set the values? Can I set your values? Because that would be... You can! Wait, this is so straightforward! Do you work now? Oh! Oh! Oh, look at it! But why? Why does it do that? Logarithmic. No? No, why? Why are you so big? You're such a big value, son. You're 20,000. Why? Why does it do that? Yeah, because I set it to 700 and now it's way up there. Why? Integer values. Just put that. Wait, that sort of looks right though. Yeah, is this correct? Go up to 10. Oh, why don't you go higher though? Why do you stop evaluating? You capped. Are you capped at a value? Oh, is this gonna be a thing where it has like... Oh, I think you can only have a specific range of... Yeah, I think you're gonna have like a specific range of just like 1800 something. Like the MIDI standard type thing. Which is really cringe. Why do you not let me do more? Let me do my values. Because like the thing is, this is nice, being able to set this to a really big value. Oh, yeah. Yeah, see. This only goes up to... Oh, but it's still... Is it adding them? No, because it's changing it. Okay, anyway. I need this to be a logarithmic value. Maybe this doesn't... No, that it kind of does need to be a logarithmic value for this also. Ooh. You do linear over there. How you doing? Ooh, whoa, I'll be Oh. Oh, what? It doesn't have enough precision to go down all the way. That's not particularly great, but I feel like something's broken. If I do that, yeah, look at it. Why are you the way that you are now? What is your range? Initial value 10. That's right. I'm gonna save the patch, reload it. I just want to see if it works. Plugdata. LS HLP. Oh no. Oh, right. No. No, why? No, why? Oh, we need to give you an initial value as well. You can get an initial value of 20,000. And then also you can get an initial value of 0, or well, 10. I'm gonna use the same load bang from over here. I really don't understand why it's doing this. Why is it changing my initial value when it gets inside? Let's just put a float on the in and out. Float. I wanna see what it's doing to itself. Oh, look, it's not doing shit. But actually, I probably need a number box, right? Like NBX, number box. Type that in there. Is it that? No. Why? Nope. Give me a float number. Oh, is that upset? So I'm breaking this control. Oh, our parameter died too. That's not HPF. And then we need to actually set your range. Oh, but why aren't you showing me the extra dialogue now? Ten to 20. Okay. Okay. Okay, this is a bug that they're gonna need to fix at some point. 10 to 20. I think this is just broken, probably. For me, at least. I think I need to move this and then it'll update. Ooh, oh, that's so bad. Why? Show me what's happening. Why is it up at Narnia? Yeah. Oh, did I change this from... Yeah, okay, no, that makes sense. What? Wait, do I need to enter you into the feedback loop? Oh, you're just so bad now. Why? You? Oh, was it just always this bad? I am so sure I messed something up. Is this range? This range is nothing. Is there an alternative to this? No. Compatibility note. PD versions, the higher frequency output gain was incorrectly greater than 1. Usually it's only slightly so, but noticeably if the cutoff was more than quarter of Nyquist frequency, this problem was fixed incorrectly. And now hopefully fixed in that to get the old. Yeah, add the compatibility message. Okay. It's fine. I'll live with it for now. A big old learning experience for me. That's weird. Bizarre. How do I set this to be full blast? Yeah, this is only input. That's only output. How do I set this to actually do its thing? If I set this to just that, does that fix my problem? You know, my problem. It, it didn't remember. You didn't remember what I told you. Open a page. Except not like that. I want to see what Mr. Bristow does. Edit. I'd like to know. How do you handle this? How do I even find your output value? Oh. Oh. I don't think I get to know. I don't think I get to understand. I don't do. Oh, nope, I maybe can. I do. Nope. Nope. I really would just like to know. What is the standard way of doing this? Ooh, maybe. DAC. You do use DAC? You do use DAC. Okay. Okay then. Now remember, this is only left channel. Yeah, so that works. I don't think we're gonna get to do the feedback automation thing tonight. I need to figure out why it's breaking this range. I think I need to just straight up do a tutorial on that, and should be able to get it working. But this is basically the tool, though, that I want it to make for this. I think it does serve its purpose in doing exactly what it was supposed to do. Because you can see it does actually filter out and then filter back in. We will need to probably like test around and see if it does the other things eventually. Like the automation is going to be the big thing for me doing the next section. Yeah. After that, it's going to be really fun stuff. We're going to switch to using other filter types in this type of setup. I think that will be the next goal. My big goal is going to be figuring out this logic, actually making this good, not be this cringe to calculate and have so many load bangs everywhere. I think that's going to be the next installment of this. This actually does exist here. Yep. 2 instances of thing every time. Very inefficient, probably. I don't know. Yeah, I think that's gonna be it for today's stream. Yeah, sorry it was like pretty just messy overall, but that's kind of the heart of this, I guess. When you just don't have any idea what you're doing, which is me right now. I don't know. I don't know what this is. How? And you obviously have seen I'm very bad at math. Smile. So we will improve. As we go, we make cooler tools and we make them more efficient and we make them good. This initial stage is going to be terrible though. Just lots of learning. But we awesome things. I promise you. And it'll be very cool. So for the next stream, I think what I'm going to do is I would very much like to know how automation works. I think that's very, very, very important for the type of tools that I want to build. B, I would like to have a bit more structure of figuring this out, but this is just unfortunately kind of the nature of learning this type of thing is you need to do the thing a bunch of times and get it wrong a bunch of times until you get it right. And programming, I feel like, is the exact same thing. You do things wrong until you do them right. And that's kind of my thought on this. I'm gonna probably be yelled at some point by some very good plugin person, or they're gonna be very, very nice and teach me very cool things. But it's not about me, it is about us, because I will be sharing this with you, even if it is a bit messy. Yeah. Thank you for chilling out. Everybody like popped out in the stream. I think that will probably be it for me. 5-hour stream, not bad for our first stream again. Had some complications. That's all sorted now. I think the stream is probably pretty stable. But I'll check more settings and figure out how things are going. Yeah, thank you so much. Take it easy, everyone. Bye bye.